Hey guys, so welcome back. Today I'm going to be doing a Python tutorial series. So this is the first episode in the series. It's kind of an introduction showing you how to download Python, how to install it, and then going into data types and variables. So the first important thing to understand about the Python programming language. So don't worry if you've never programmed before. I'm going to be going over everything very slowly and in depth so that you can understand. I recommend that you follow along with everything I'm doing in the tutorial. Pause the video at certain points, rewind if you don't understand. It's important you understand these parts so that we can move forward into more complex ideas. So obviously the first thing that we're going to have to do if we're going to learn Python is we have to install it on our computer. So we're just going to go to the Python website up here, python.org/downloads right here. And all you're going to do is just click download Python 3.6.1. Now, I'm not going to do that because I already have Python installed and downloaded on my computer, but pretty much once you download this, it's going to pop up down here in your downloads folder. Just run the exe. It's very simple, and you'll be running Python in no time. So now pause the video, go ahead and do that, and then we can go to the next steps. Okay, so once you've done that, you're going to notice that you have an application that looks like this. It's called IDLE Python, and then it'll have the version. So I'm using version 3.5. Don't worry if you have a version that is larger than that, so 3.6 or even one that's before that. Most of the things that I do in this will work in all the versions of Python. Okay, so go ahead and run the IDLE. You'll notice the first thing that pops up is the Python shell. As you can see at the top here, the shell. Now, this right here is not where we're going to write all our programs. It's the console, kind of. So here I can type any lines of code. For example, I want to print a name like this, and it'll run right away. So that's not what we're going to do. You can play around with this if you want, but we're going to go to File, and we're going to click New File, and then here we go. So now we have a new document that we're going to be working on and we're going to be programming in. So I'm going to go ahead and I'm going to save this right away as tutorial 1 into my tutorial folder, which I believe is on my desktop right here. Yep, right there. Awesome. Okay, so there we go. We've saved it, and now we're ready to learn a little bit about data types. So pretty much Python is a fairly basic language in comparison to a lot of other ones. A lot of things that it does is more simple than other languages, but it is important to understand the basic data types. So there's 4 main data types in Python. There is a few more, but we're just going to talk about these ones right now. The first one is an integer. So that can be a short form int. That stands for integer. Now, an integer is any number, so such as 1, 4, 76, any whole number. It's important that it is a whole number. It could be a negative number as well, -5, 0. Those are all integers. Okay, now we have strings. Now the short form for strings is str. Now pretty much a string is anything embedded in quotations. So like this, this is my name, Tim. That is a string. And then we also have something like this. This would be a string. And even like this. This would be a string. So although there is a number in here, since it is between these 2 quotations here, it is a string. So even if I did another number like that, string. Now it's also important to understand that it doesn't matter if you use the single quotations or the double quotations. Sometimes we use the single quotations because inside of our actual quotations we want to use the double quotations, or maybe if we use the double quotations because we want to use the single quotations inside of our actual string, like that. Okay, so those are just a few examples. Now we have Boolean variables, or data types, sorry. So Boolean data types is something like true and false. So true and false, pretty basic. These are reserved words in Python, meaning that they're highlighted in yellow and that you cannot use them for variable names. That's going to be important later on. Just know that they are important words, true and false, and they do start with capitals. So for example, if I type true like this, it's not highlighting orange, right? So that's because true in Python, the keyword for that starts with a capital, so true and false. Then we have the decimals, which are the float data type, like this. So anything with a decimal floating point, so 1.23, anything like that, any decimal number with a floating decimal point would be a float. Okay, so those are the 4 basic data types. There is a few more that I'll go on to later on, but you just have to understand these ones right now. So now that we know these data types, I'll give a quick little quiz here. So I'm just going to put a few things right here. And then I want you to pause the video and go ahead and try to determine what type of data type these things are. Okay, so go ahead, pause the video, and then I'll go over the answers in a second. Okay, so we'll start with the first one here, hello. It's the same example that I have up here, except in single quotations, so we can see that it is a string data type. Okay, so that is the short form str. Now we have the number 123, that would be the integer data type. We have another number here that has a decimal point, so 3.22, that would be a float. We have the keyword true. This data type is a Boolean data type. Then we have 2 in quotations. This is very important. We don't want to get this mixed up. This is a string. Some people may think that it's an integer because it's 2, but no, it actually is a string because it is inside of the quotations. And then same thing here, 3 inside of the double quotations, again, is a string, not an integer. Okay, so now that we have an idea of the basic data types, I'm going to show you how to create a variable. So pretty much you may have heard of variables before in math or something like that. In math, we tend to use x as a variable. We say x may be 5, x may be 4, anything like that. It's the same thing in Python. Now, declaring a variable in Python is very easy. All you have to do is type the variable name. So in this case, I'm going to use name, and then simply give it a value. So this value, as you may remember, is a string. This is my name, and I'm just storing it in the variable name. Now, if I want to access that variable, I want to see what that variable is, I can print it to the console by simply typing the variable name, which is name. So now we'll see what happens. If I run the program, just going run module, I'm going to use F5 from now on. So that's the thing, and you can see it prints out Tim, just like that. Okay, now say we did that, we have name equals Tim, we printed it to the screen. Now maybe we want to change that variable. Well, it's very easy. Again, all we have to do is just type the value name, and now maybe we're going to change it to Bob. And now we want to see what the new variable is, so we will print it to the screen. We'll print name, click F5 to run that, and we'll see name, and Tim, and then Bob. So like we have here, name equals Tim, print name equals Bob, print name, right? So we've set it like that. Okay, so that's pretty basic. Now you can create variables of different data types. So for example, if we had a variable age, I would use an integer data type, so like 18 for that variable. And then again, if I wanted to print it to the screen, I would type print and then the variable name like that. Okay, 18, perfect, right? So we printed that to the screen. Again, if the variable names, there's a few restrictions on variable names. So here you just see I've used 3 lowercase letters. Your variable names can contain underscores. They cannot contain dashes. They can only contain underscores, text, and they cannot start with a number, I believe. So if I try to do one name equals 2, for example, I run into an invalid syntax error because we can't name a variable starting with a number. Now I can end it with a number, I believe. Let us try. Yep, so that's fine. It's let us do that. Name equals 1. I could do name underscore person, maybe. Yeah, name underscore person. You see if I run that program, everything's fine there. But I can't put something like a star in my variable name. You see how we've got an invalid syntax there, right? But this is because these symbols represent something else in the Python language. So just know for names, we can use capitals if we'd like. I could use name like that. So run the program. That works fine. but I cannot start it with numbers, so I cannot put a number there, and I cannot contain anything other than underscores, text, and numbers in or at the end of the variable name. Now, here's a quiz for you. If I make a variable called name, do another variable called name, are they the same thing? Now, that's a good question. Are these two the same thing? No, they are not the same thing. So capitals do matter in Python. The all capitals variable name is different than the variable name. So again, name like this is different than all of those variables there. Okay, so I think I've covered a little bit on variables and data types today. This is the complete basics, just wanting to get everyone caught up. In the next video, we'll go into some more advanced things, maybe operations of variables, adding them together, subtracting, multiplying, Boolean conditions, things like that, okay? Hey guys, so welcome to the second video in the series. If you remember in the last video, we talked about data types and variables. We went briefly into some of the things that Python can do. Today I'm going to be talking about operators, and we're going to be doing some print statements, some input, a few small console applications, and just applying some of the knowledge that we've learned. So pretty much the first thing I want to do is I want to go back and I want to review what we did in the last lesson very quickly. So we talked about variables and data types. So for example, the x variable, we could set it to something equal to 2, like that. A name, we made equal to our name, right? So I make that equal to Tim. So there we go. We have the name right there equal to Tim. We'll start with that, okay? Now, if you remember in the last one, I didn't talk about this, but I used something called print. Now, the print statement pretty much takes an argument. So inside of these brackets, the thing that is inside that brackets is called the argument. So it takes a string argument usually. So I will give it the name. So now you'll see, again, we did this in the last one. Just want to review. I'm clicking F5 simply to run the program. When I go to the console, it simply puts Tim onto the console, just like that, right? Okay. Very basic. We already did that. So now let's say, well, we want to do something else. So let's print here. And we're just going to put a string, and we're just going to type this in ourselves. So let's say, hello, comma, what is your name? That's going to print to the console. Now we want to get what the user's name is. Now there's a way to do this in Python. It's very simple. We're going to make a variable name. It makes sense to put the variable name here. Do an equal sign because it's a variable, right? And we're going to type the word input, just like this. Now what's going to happen if I run the program here, I'll show you, is it's going to say, hello, what is your name? And it's going to actually allow me now to type into the console, which I couldn't do before. Now nothing happens after when I click enter because we don't have anything else after that, but it's allowing me to type. Okay, so now, well, we want to print out what the name is that was said. So let's just simply type print and then name. All right. And we have, hello, what is your name? I say, oh, well, my name's Tim. It says Tim. All right. Now, well, we just printed out the name, but maybe we want to go a little more advanced than that. We want to say, well, hello, Tim. How are you doing, Tim? Something like that, right? So I'm going to just put a comma here. I'm going to separate these two things. And I'm going to put in a string. And I'm just going to type what I'd like to type. So I'm going to say hello with a comma. And then you see that I have this other comma here that is outside of the quotations, meaning it's not a string. It's actually just separating the two arguments in here. And you'll notice what happens now when I print is it goes, hello, what is your name? So I say, oh, well, my name's Tim. It says, hello, Tim, right? So that's pretty straightforward. I hope that's easy to understand. We're just using the input to get an input, and then we're printing it back out to the screen. Okay, so let's go into the next part of this. Now we'll use that again later, but let's talk about operators. So operator, that term may sound familiar to you. In math, we use things called operators. So these four operators hopefully should look familiar to you. This is a plus sign. This is the addition operator. We have the minus sign, which is the subtraction operator, the division sign, which is the, well, division operator, and then the multiplication sign, which is, again, the multiplication operator. So there's a few more operators that we'll talk about, but these are the four basic ones in Python. Now, you remember how I talked to you about data types? This is where this comes in. When we use these operators, it's important that we use them on certain data types. So for example, in math, I could do something like 3 plus 4. Right? So what does 3 plus 4 equal? Well, that is equal to 7. So the computer can actually do that math operation by using that operator to return those values. So let's give an example here quickly. So I have, let's do num1. We're going to use variables here. Remember, I can use a number in the variable as long as it's not at the beginning. And I'm going to give it a value of 45. And then we'll do num2, and we're going to give it a value of 3. Now, if I want to print to the console, let's say num1 plus num2, well, you can guess what that's going to give us. It's going to give us 45 plus 3, I hope, if this is not an error. Yeah, so that gave us 48, right? So, oops, didn't mean to make that full screen. Num1 plus num2 is 48. All right, so now what about minus? Let's try this. 42, basic. We can do multiplication here with the multiplication sign. There we go, 135. And then we'll try again with the division sign just to show you all of them. We get 15.0, like that, okay? So that's pretty straightforward, those four basic operators. Now in Python, there's a few more operators that we want to talk about. Now, for example, in math, we have something called exponents, right? So how do we do exponents in Python? Well, it's actually 2 stars is how you do an exponent. All right, and now maybe there's something called integer division, which I'll get into later, but I'll just show you the operator for it right now. It's 2 slashes. That means, I'll give you an example, a math example here. 64 divided by, let's do 10, would give us usually in math a value of 6.4, right? That's if you use one division sign. Sorry, what am I doing times? I mean, divided by would give us 64. I have 6.4. But now if we do 2 division signs here like this, it actually gives us a value of 6. That's because it just, it doesn't worry about the remainder at all. It just tells us how many times 10 can go into 64, and that's all. It can go in 6 times evenly. So it gives us a whole number as our answer. That's called integer division, this double slash like this. Okay, and then we have another operator, which is actually the modulus operator. So this is the percentage sign, and this gives us the remainder. So here, if I do 5 modulus 2, then the remainder of that is actually 1, because 5 divided by 2 is 4, then with a remainder of 1, right? So it's not going to give us the decimal points. It's, again, just going to give us the remainder. If I did 5 divided by 4, again, the remainder is 1. 5 divided by 3, the remainder would be 2, like that. Okay, so that's what the modulus sign gives us. So we'll put modulus here. And then there's probably a few others that I'm forgetting about, but we can go into those later. So now, same thing. Let's keep using our number variables here. And now let's introduce a third variable called num3. Now, I want to show you how we can use the variables. So num1, and let's see if you remember what this operator is. So that's the exponent operator. So that means num1, which is going to be our base, which is 45, raised to the power of 4, because we're going to use num2. And we can print num3. Press OK. And you can see we get a pretty large number. That's because of how exponents work. And then same thing here if we want to do maybe integer division. Let's see what we're going to get. We get 11, right, a whole number, and then say we want to do modulus. We get 1. Okay, so now let's tie all of these things together with the operators that we've used, the variables, the prints, and the inputs. So let's start by just doing a little print statement and saying pick a number. Okay, pretty basic. We're going to pick a number. And then we're going to take the input. So we're going to say num1 again is equal to the input of that. Okay, so we got the input of num1. Now let's say print pick another number. All right, so now we're going to pick another number. So we're going to do num2 is equal to input like that. And now what we're going to do is we're going to introduce our third variable. So we'll call it sum, because we're going to add these is equal to num1 plus num2. And now actually you can't use sum because it's a reserved word, so let's just do in all capitals sum, because remember how we talked about variables, capitals and lowercase are different. And then we're going to print to the console the sum like that. Okay, so we run the program. It says pick a number. Let's pick a number. Let's say 4, and let's do 32. Now what do you think it's going to be? Oh, oops. Okay, so yeah, sum1 equals num1 plus num2. Okay, so this is why I talked about data types. So I'm actually happy this happened. It's because what actually happens when we get the input of something is it gives us the type of a string, which in this case is not what we wanted to do. So you saw there, I'll run it again. It's a good mistake that this happened actually. We have 4 and we have 3, and it gave us 43. That's just because we added the string 4 to the string 3. So that simply gave us 43. But now we know in actual math that 4 plus 3 equals 7. So if we want to do the integers, we have to actually convert these variables into integers. So in order to do that, remember I showed you the keyword int like this before. We're just going to put brackets around our two variables here like this, integers. And now hopefully we should get the correct answer when we do 4 and we do 3, and you can see we've got 7. So I didn't mean for that to happen originally, but I'm happy it did because it shows us why data types are important. So when we take the input of something, we're typing it from the keyboard, and that is actually a string. So here we can print again. Don't worry about what I'm doing right now, but I just want to show you the type, which is going to give us, if it's a string, if it's an integer, of num2, just to show you what the type actually is. So we pick a number, we pick 2, and we pick 3. It tells us that 3 is actually a string. So that's why when we added originally 3 and 2, or 2 and 3, or whatever it was, it gave us just them added together. So 2 and 3, rather than what it should be, which is 5. Okay? Now same thing here. If we had a number, and we wanted to convert it into a string, all we would do is we'd type str around the number. So for example, 3. And then that would give us 3, just like that, so a string. So now we've kind of gone over conversion of variables, conversion of numbers, data types, how to get input from the console using the input like this, and some basic operators of Python. So review this. I hope you followed along, and then in the next lesson we'll move into some more advanced operators, and we'll maybe start with conditions. Okay, I hope you enjoyed. Please subscribe, like the video, and I'll see you in the next video. Hey guys, welcome back to the third video in my Python programming tutorial series. Today we're going to be talking about something called conditions. So I hope you remember from the other videos, we talked about input, printing, we did variables, data types, and then we talked about operators. So operators like plus, minus, division, integer division, modulus, right? Multiplication, all those operators. Today we're going to be talking about a few more operators and then getting into conditions. So here in my file right here, I've put down 4 basic comparison operators. So pretty much a comparison is something that's going to return a value of true or false. So here we have, let's say if a real world example is Tim equal to Joe. Well, no, they're not, because Tim obviously is spelled differently than Joe, so that's going to be giving us a value of false. Same thing if we want to go into numbers, we say is 18 is greater than 2. Well, is that true? Yes, it is. So that condition gives us a value of true. It's a very simple concept, but it's something that we have to understand as we go into decisions later on, which will be in the next video. Okay, so these comparison operators, I'll read them off and just kind of give a definition of each of them. So the first one, can you be a less than or a greater than sign? Same thing with the second one, right? So it's just going to compare if something's less than, greater than. Usually these are used for integer values, that data type. We also can use them for strings, but it's a little more complex, and I'm not going to get into that right now, maybe in a more advanced tutorial later on. Now the equivalent operator, so the equal sign here. Now a lot of people think, well, if I'm comparing something, why wouldn't I just use one equal sign like this? Well, that's a very good question, and a lot of people get mixed up on this. It is actually two equal signs. That's because in Python, the one equal sign is a declaration operator. So for example, if I put a variable x and I want to set it equal to 4, right? This is what we do with the one equal sign. We're setting values, right? So when we did name is equal to Tim, things like that, we're using one equal sign. Now, if we're going to check something, we're going to compare them, we have to use two, because two equal signs and one equal sign have a very different meaning. So it's important to keep that in mind, that the comparison operator for equivalency is two equal signs. Okay, the next one is not equal to. So we have an exclamation mark, and then we have the equal sign, like this, okay? So an example of not equal to, because some people may get confused here, is to say if 4 not equal to 5. Oops, what did I type there? Not equal to 5. Okay, so what do you think this would give us? Just think about it for a second. Well, what it's actually going to return to us is true, because the condition is if 4 is not equal to 5. And here we can see obviously 4 is not equal to 5. So now again, if I give another example, we put 5 here. We say 5 not equal to 5. Well, that would return a value of false, because 5 is indeed equal to 5. Now we can do the same thing with strings. So for example, we have hello. Oops, spelled incorrectly. There we go. And Tim. Now, you can probably guess by yourself that this is going to return true, because Tim is indeed not equal to hello. Okay, it's pretty straightforward, but a lot of people may get mixed up with the not equal to if it's returning true or false. Okay, so those are the 4 basic comparison operators that we're going to use. So we have equal to, not equal to, and then greater than and less than. So greater than and less than, again, we use for numbers. So 1 less than 2, again, that's going to return true, like that, okay? So now we're going to start printing some things to the console and maybe doing a little bit of a quiz here, just to see how you guys are going to do. So a Boolean condition, I'm going to store it in a variable. So I'm going to say name, oops, actually we're not going to do that. We're just going to print to the console 2 less than 3. Okay, now you guys guess and tell me what you think is going to be returned to the console. It's either going to be true or false. I'll give you a hint right now. Now it gives us a value of true. That's because this condition, 2 is less than 3, is true. It's equal to 3, right? So now if we switch the sign and we make it greater than, like that, well, you can guess what's going to come up. So we click enter, and we get false. That's because this condition returns a value of false. Okay, now we'll do another condition here, all right? Hello equal to hello, okay? And guess yourself what this one's going to return? False, okay? That's because they are spelt differently. Now we're going to do the not equal sign just to show that one as well. Hello not equal to hello, and we'll see that gives us true because they are not the same. Fairly straightforward, but a lot of people do get these things mixed up. Now I'll show you what happens when I try to just do one equal sign, like this. See, we get keyword can't be an expression. That's because we're trying to declare a variable here, but we cannot do that, okay? Because we're just using one equal sign here, we need to use 2, all right? Okay, so now let's try another example, maybe a more advanced one. This is a little bit of a trick, okay? I want to see if you guys remember from my last tutorial what I talked about. So take a guess right now what you think is going to be returned. Do you think it's going to be true or do you think it's going to be false? Well, it was false, okay? That's because, again, what we talked about in Python, capitals matter, right? So any capital letter is different than a lowercase letter. So something like this, yeah, it's going to return false, all right? It's important to understand that. Okay, so we've very briefly gone into conditions now. I'm going to write a few on the side here. You guys can go ahead, I'll put them in print statements and test yourself and see if you get them right or not, okay? I'm going to add a few tricks from the other lesson, try to kind of apply some of our knowledge and see if we can get them correct, okay? So just give me a minute here. I'm just going to write a few out. And then we'll go through the answers afterwards, okay? So you know what, we'll just do these ones for right now, and we'll do a few other examples. Okay, so these are a little more advanced than what I was talking about before, but they are conditions. We have a left side of the condition, and we have a right side of the condition. So I hope you've taken a guess now of what you think these are going to be, because I'm about to print out the answer right now. Okay, so we've gotten true, false, and false. All right, so for the first one, 2 less than 3. That's an example I already gave. That gives us a value of true because that condition is true. Now we have 2 minus 3 plus 4 greater than 5. So you can do the math there and see that that is going to be false. And then this one, some people may have gotten a little bit confused on, because I actually used the words false and true in my condition that's going to return false or true. So I have print false equals true. Well, is false the same thing as true? No, it's not. So obviously we are going to be returned with the value false. Okay, so we've talked a little bit about conditions now. In the next tutorial, we're going to be doing something called decision. So I'll give you a sneak peek on what that is. Something like this, okay? So stay tuned for that. The next episode should be up tomorrow. And yeah, I hope you guys enjoyed the video. Go ahead, like and subscribe, and yeah, share with your friends. Thanks. Bye. Hey guys, welcome back to the 4th video in my Python programming tutorial series. Today we're going to be talking about decisions. So we're going to be using the if, else, and elif statements in Python. So pretty much I gave you a little example last time on what these are, but if condition equals true, then do this. Sorry, not his, do this. Okay, so pretty much the syntax for the basic if statement, which is what we are going to cover first, is like this. So if you remember my last tutorial, I talked about conditions. If you haven't seen that, go back and look at that first, because that's going to be an important part of today's lesson and you have to understand that. So if condition is true, then we are going to do this. Now let's just dig into the syntax a little bit here. So you're going to start with the keyword if, then we're going to put a condition. So the condition could be something like this: if 1 is less than 2, if tree is equal to plant, something like that, okay? Anything that can return a true or false value. You can use variable names. You can say if x is equal to y, anything like that is condition, and it uses a conditional operator like I talked about in the last video. And then you are going to end your condition with a semicolon, or sorry, not a semicolon like this, with a regular colon, and then you are going to simply click enter, and it should tab you in one line. Now it's very important that you have this indentation. If you have your code like this, it's not going to work. Python reads the lines because of indentation, so it's very important that you have whatever statements you want to run after the condition returns true indented properly. And this will also be very important as we move further on in different tutorials, and we have lots of different indentation levels within the program. Okay, so let's do a real example now instead of this kind of pseudocode here. So we'll start off by just getting some input from the user. So let's say, let's get their age. Okay, so age is equal to input like this. And then just if you put something inside of the input like this, it actually gives a prompt to the user. So we'll say input your age like that. And then we will say if the age is equal to 16, then we will print to the screen, hey, you're 16, like that, okay? Alright, so let's go ahead and just test it out right away. I know I haven't really explained it, but I just wanted to show you how this works. Okay, so we have input your age. So I'll say 2 as my age, and we can see that nothing happens, okay? Now I want to show you one more. I hope you've caught this trick already from what I talked about in the last videos, but we'll see. Now you notice here, I'm going to put in 16, and nothing's going to happen. Now the reason for that is because 16 here is different than the 16 that we get from age. If you remember, whenever we're getting a number or anything from the console, we actually get it as a string. So this 16 that we're getting actually looks like this. Now in Python, again, we have different data types, right? So this is an integer data type, while this is a string. So when we're comparing integers and strings, they're different. So we have to convert our age variable into an integer before we can compare it like that, okay? Now we'll try again. Say if int age equals 16, so now we put 16 in and says, hey, you're 16, like that, okay? Perfect. So that's pretty straightforward. Now we can also do some other conditions. So let's do a greater than 16 now, okay? So this is another conditional operator that we talked about before. And yeah, we'll go ahead, we'll try it now. So we'll say 15. Now nothing happened because obviously 15 is not greater than 16. Now if we put in 17, it works. Okay? Great. Alright, and also I just want to show you there's another operator that we didn't talk about last time, a conditional operator, and it's the greater than or equal to and the less than or equal to. So to convert your greater than sign into a greater than or equal to sign, all you have to do is add an equal sign like this, and now anything greater than or equal to 16 will work. Whereas before it had to be strictly greater than 16, and same thing with the less than sign, like that, okay? I just forgot to talk about in the other video, so I figured I'd put it in here. Alright, great, so let's go into another example then. So let's say, it's great, it's telling us we're 16. Or let's, in this case, we're going to be older than 16, right? So, hey, you're older than 16. But what if we want to message when we are younger than 16? Well, the way to do this is using something called an else statement. So the syntax for this, it simply has to come after an if statement. You can't just leave your own else statement like this. That will not work. It has to be after an if statement is placed, and then all you have to do is put a colon and click enter and make sure the indentation is the same as the indentation for the first if. Okay, so now we're just going to print you are younger than 16. Okay, and we can go ahead, we can try this to see if the else is going to work, and we say, well, we're 15 and you are younger than 16. Great. Okay. So just to explain this a little more, how this really works when we're reading through the code. Well, Python reads code line by line like this. Now when it reaches this if statement, it checks this condition to see if it is true or false. So since this condition was false in the last example, we say if false, it says, okay, so we're not going to run this line of code. We're going to skip to the else statement, and we're going to do this. Okay, so if we had typed anything in that does not return true, so makes this condition not return true, then it would go to this else statement like this. Okay. Yeah, and then same thing, say we type in a number 17, and that is greater than 16, it's not going to do the else statement, it's just going to do the if statement. Okay, I hope that makes sense. Now we're going to go into another layer. Okay, so let's get into a new example here. Let's talk about height for a roller coaster. Okay, so for some roller coasters, you have to be taller than a certain height, and you actually can't be too tall, right? So again, we'll get the input from the console. So we'll just say height is equal to input, and we're just going to do this in meters, like 1 meter, 2 meter, 3 meter, just to make it really easy. Okay, I know that's not a realistic height, but just for the purpose of this example. So we say height is equal to input. Again, we have to remember that when we're going to check the condition, we have to make sure we put it in the int, because as we get it from the console, it's going to be a string, okay? So we'll say if height is less than 1 meter, we're going to say you cannot ride. So we're going to print to the screen, you cannot ride, okay? Now, we only want to allow the user to ride if their height is in between 1 meter but less than 2 meters. Okay, so as you can see, I've introduced a new word here called elif. Alright, so this means if this condition up here is false, then we're going to go to this one. We're going to check if this condition is true or false. If it's true, we're going to run whatever's in here. Otherwise, we're going to keep going. So you can have as many elifs as you possibly want in a decision statement like this, okay? You can only have one else though, because else is just the default. So anything you type in that doesn't equal any of these statements, so like if isn't true, elif isn't true, the other elif isn't true, then it'll go to the else statement, okay? So elif, the height is, so if it's less than 1, you can't ride, and if it is greater than 2, you also can't ride. So we're going to say you cannot ride. I'm going to say, and we'll say over 2 meters, and then we'll put here, just so we can distinct them, under 1 meter, okay? And then now we're going to add in the else statement like this. We're going to say print you can ride. Okay, so I know I just did a lot there, so we'll go through it quickly. We pretty much have a condition up here. We already talked about the if statement, so if this condition is true, we're going to print this, and we're going to skip everything else. We're not even going to bother reading it because we know that it's not going to be any of those conditions. Okay, so now we do the elif here, right? So we say, well, if this condition's false, we're going to go ahead and we're going to check this condition. So we say, oh, well, this one's true. So then we're going to execute this line of code, which is the print, and we're not going to do this else statement. Now say we go through these two, and they're both false. Okay, so this returned false, and this returned false. Then we're going to go to the else, and we're automatically just going to print whatever is in the else statement like that. Okay, so we'll go ahead, we'll run the program, and we'll try it out. Make sure I haven't made any errors here. Okay, so the input, I didn't give a prompt, so I'm just going to type in the height, a number. All right, so we'll say 1. You can ride. Great. Okay, that is because, again, we have the strictly less than sign. Now, if we wanted it to be, you have to be over 1 foot, we just put an equal sign here, and then same thing here. Okay, so we'll do that, and now I'll show you again. If I put in 1, you cannot ride under 1 meter. Okay, so less than or equal to 1, right? Okay, let's try again now. We'll do it maybe a number greater than 2, so let's say we put 4. It says you cannot ride because you are over 2 meters. And then again, if we do like a decimal number, maybe 1.1. Okay, so we've run into an error there. That's fine, just because we can't convert a floating decimal point into an integer. But yeah, I hope you get the point from that example here. These are just the basic if, elif, and else statements. I'll do one more just to show you here. We could do another elif here saying, for example, if int height is equal to, remember we do 2 equal signs, right? Not 1. Then we're going to say print wow, you are tall. Okay, so as you can see, we can do infinite elif statements like this, and we can only have one else statement and one if statement at the beginning. Okay, so we'll run this one just to show you one more time how this works. I'll put in 5, so 5. You cannot ride over 2 meters. Okay, so that's because what actually happened here is we went if, we checked this condition. Now it turns out that 5 is greater than 2, so we did this one, and we didn't bother reading the rest. Now, if I wanted to change this so that it would check the 5 first, all I would have to do is put this elif statement, I'll do it right now, above the other elif statement, like this. And now, if I type in 5, it'll work. Wow, you are tall. Okay, so that's it for the if, elif, and else statements. In the next tutorial, we're going to go into something called chained conditionals and do some more advanced examples of this. We're going to do some addition, subtraction, and some more things with other operators. Okay, so I hope you enjoyed. Please don't forget to like and subscribe the video, and I'll see you again tomorrow. Hey guys, welcome back to another video. This is the 5th video in my Python programming series, and today we're going to be talking about chained conditionals and nested if statements. So pretty much chained conditionals are just adding multiple conditions in one line with using words like and, or. Okay, we also have keyword not that we're going to talk about as well. So if you haven't seen the last videos in my series, go ahead and watch those now because they are a prerequisite for this video. Alright, so let's get right ahead and start. So if you remember before, we have something called conditions. So for example, if we have the variable x, I'll set that to 2, and the variable y, which is equal to 3, we could have a condition like x equal y. Now obviously we know from the last video that this is going to give us a value of false. Oops, and I cannot type today, sorry. And that is because 2 is not equal to 3. Pretty straightforward. I hope you have all understood that from the last video. Alright, so what we want to do in this now is we're going to want to check multiple conditions. So we'll put a condition here. So if x is equal to y, and then we can put a word in like this, the and word. Now we'll add another condition. So if x plus y is equal to 5. Okay, so this first condition is going to give us a value of false. So if x is equal to y, because they are not the same. But now x plus y does indeed equal 5. So that is going to give us a value of true. So where I'm highlighting, we have true, and then where I'm highlighting now again, we have false. So because we have the keyword and, this if statement is not going to run. So I'll put a print here just to show you. We're going to print out true, or let's just say ran. And you'll see when I run the program, nothing is going to happen. That is because when we use the and keyword, it means both conditions on either side must be true. So if we change this to something like if y is equal to 3, now that is going to be true, and we'll print out ran. Okay, so that's pretty basic. Now let's do the or keyword. So we'll put or right here, and we'll change this condition back to if y is equal to x. And now take a guess on what you think is going to happen. Well, pretty much with the or keyword, it means either of the conditions have to be true. So if y is equal to x or x plus y is equal to 5, then we are going to run this line. Now since x plus y does equal 5, we have a true here, and again y is not equal to x, so we have a false, and you'll see that the program is going to run. That's because only one of the conditions has to be true for it to run. Okay, so that is the and the or keyword. They are pretty straightforward and pretty basic. Now I'd like to point out that you can actually add as many conditions as you'd like. So now I can have an or, I can have an and, I could have another condition. I could do as many as I'd possibly can imagine and as many as I'd like to do. So now we'll put an else statement in here, and we'll change this just a little bit to use another keyword. We'll just put a sad face here to show that we didn't run it, that we ran the else, okay? So now there's something called the not word, okay? So we're going to put not right here around it, and then I will show you what it does. So pretty much not reverses anything that you have inside of the brackets of the not. So in here we have if y is equal to x or x plus y is equal to 5. So we know again that this gives us a value of true. So now since true is inside of the not, true becomes false. Now we have if false. So obviously that's going to bring us to the else statement, which is going to print the sad face. So I'll show you that that does indeed work. So we have the sad face, right? Now if we change these so that both of these conditions are false, you'll see that we have false, false, which is going to give us an overall value of false. And then we're going to have the not, which is going to change that into a true and will allow us to run it, just like that. Ran. So yeah, so that's how the not, the and the or work. And now let's get into nested loops, or sorry, not nested loops, nested if statements. So we'll do a basic if statement here. If x is equal to 2, if y is equal to 3, and then we'll add our else's like this, and we'll put some print statements in here. Okay, just give me a second while I type out the print statements, and then we will go into what this is going to do. X equals 2 and y equals 3. So you may have guessed already, but pretty much we can actually add as many if statements embedded or nested as we'd like. So I could add another if statement here and just constantly keep checking. Now the reason I showed you chained conditionals is because if I didn't want to go through the hassle of adding all of these nested statements, I could just do an and right here and check for another condition, but sometimes we do want to do nested statements. So we'll say here x equals 2, y does not equal, 3. Okay, so I know I just did that pretty quickly, but let's walk through it now. So we have if x is equal to 2, then we're going to run whatever is in here because it is indented. So now we come in here and we say, well, is y equal to 3? Let's say it is. Now we're going to print out this statement and we're going to be done with this loop, with this bit of code. So we're going to skip down to the end of the program where we have nothing else. So let's say we do another example, x is equal to 2, but y equals 4. So that means we're actually going to run the else, which means now we've got print x is equal to 2, but y does not equal 3. And then the last case is x is not equal to 2, so we don't even bother checking if y is equal to 3. We just go down and we print x does not equal 2. So we'll change around the variables and we'll show you how this works just very quickly. So we can see x is equal to 2 and y is equal to 3. That is because obviously up here 2 and 3. Now if I want to change y and we change it to 4, we get x is equal to 2, but y is not equal to 3. So that means we ran this one in here. Now let's change it so that x is equal to 4 as well. And we can see we get x does not equal 2. Alright, so that's the basics on nested statements and chained conditionals. I hope you found this video helpful. Stay tuned for more videos. We're going to be getting into some more advanced topics, and in the next video we're going to be covering loops. Yeah, so if you liked the video, please subscribe and like, and I'll see you in the next one. Hey guys, welcome back to another video. This is the 6th video in my Python programming series, and today we're going to be talking about for loops. Again, if you missed the other videos in the series, please go back and watch them first, as it's going to be hard to understand if you haven't seen them already. Okay, so let's get right into it. Today we're going to be talking about for loops. And a loop is a new thing now if you're a beginner in Python, and I'll talk about how they work. We're going to start off by just writing one out, getting right into it with the syntax. So for x in range, and then we're going to put a number, which is going to be our starting position. So in this case, I'm going to put 0, and then a stop point, so 10. Okay, and then we're simply going to print out x. Now I know we did this pretty quickly, but let's talk about what this is and the syntax. So a for loop is going to run a certain amount of times. So in this case, we're going to start at 0 and we're going to go to 10. This means the for loop is actually going to run 10 times. So what's going to happen is we are going to have our variable x, which is right here, and every time the for loop runs, x is going to be increased by 1. Now, we can increase it by more if we'd like to by adding another comma here, but by default it is set to 1. Like this, I've just put it in so that you can visualize it. So really we have something, a start, a stop, stop, and an end. Start, stop, step, sorry, my bad. And I'll just put commas here to show you how it works. So you can see we have our 0, that's our starting number, our stop, which is 10, and our step, which is going to be 1. So I know you don't quite understand yet, but you will after I show you a few examples. So we have x is our variable, which is going to be holding the number of what iteration we are through. Now, iteration just means how many times we've already looped through this loop. Okay, so let's do an example here. All right, so we have x, and we've just started running this for loop. Now, right now, x is 0. We're going to print x, we're going to print 0 to the screen, and then we're going to add 1 to x. Now this time we come through the loop, we say, well, is x less than 10? Yes, it is. So now we're going to print x, x is 1, now we're adding 2. Okay, so now x is 2. Is 2 less than 10? Yes, 2 is less than 10, so let's print 2. Okay, and we keep going until eventually we print 9. then x has 1 added to it, so it becomes 10. Well, 10 is not less than 10, so we're not going to print out 10. All right, I know I just talked a lot there, but let's see it in action. All right, so just like I said, we print out the numbers 0 through 9. Now, this may seem weird because I have the value 10 here, so you'd say, well, why doesn't it print out 10? It's because of the way the loop works. So like I said, really what's happening here is this, plus equals 1. So pretty much this means we're just adding 1 to the variable x. You can also write it like this, x equals x plus 1, like that, all right? So we print out x, and then we add 1 to x. And we have to be less than 10 for this loop to run. So on the 9th iteration, we have, well, 9 is equal to 9 plus 1, so x is equal to 9 plus 1. We get the value 10. Now again, 10 is not less than 10, so we are not going to print out 10. Yeah, so that's pretty much how a for loop works. It's pretty basic. This is the syntax. We have for and then a variable name. So this doesn't have to be x. We could use anything we'd like to use. I could use hello. I could use any other word. It could be as long as I want, as short as I want. Doesn't matter. Then we have the word in, which is highlighted in orange, and then range. Now the range takes a different amount of arguments. Pretty much an argument is whatever's inside this brackets. So like at the beginning how I showed you, we just did 0 and 10. This means we have a start and we have a stop. So we start at 0 and we go to 10. Now I can actually put one argument in here like this, 10, and that just means that we just have a stop. So by default, Python will say, well, we're just going to start at 0 and we're going to step by 1. Now I haven't showed you the step yet, so we'll do that. So again, we're going to start at 0, we're going to stop at 10, and we're going to step this time by 2. Now what step is how much we add to x every time. So before I showed you we had x equals x plus 1. In this case, since the step is 2, it's going to be by 2, like that, okay? So let's go ahead, let's run this. We have 0, 2, 4, 6, 8, and you notice how we again do not print out 10 because 10 is not less than 10. Okay, again, we'll do another example with the step. Let's put 5 in this time. Now you can guess what's going to happen. 0, 5. It actually only prints out 2 things because we start at 0, so we print 0, and then we add 5, we get 5. Now 5 plus 5 again is not less than 10, so we are not going to print out 10. Okay, so that is the tutorial on the for loop. We're going to do another type of for loop where we're going to use something called a list a little bit later on, but right now we're just using this one. This is the basic one. I encourage you to play around with it yourself. And yeah, so if you liked the video, please go ahead and like it and subscribe, and I will see you again for another video. Thanks, goodbye. Hey guys, welcome back to the 7th video in my Python programming series. Today we're going to be talking about while loops. So in the last video we talked about for loops, and before that we talked a lot about conditions. So it's going to be important to understand those things before we can move on today to this video. So if you haven't seen those videos, go back on my channel and check those out first. Okay, so let's get right into it. Today we're going to be talking about while loops. So let's first of all just put an example down and get the syntax. Okay, so we have while condition, then we are going to do whatever is inside the loop. So it seems simple enough, but they can get fairly complex. So while condition is equal to true. So for example, this condition here, this could be a variable. While that is equal to true, then we are going to do whatever is inside of this loop. So again, we keep talking about conditions. They're very important in Python. We really need to understand them before we can move into more complex topics. Okay, so while condition is equal to true, we're going to do whatever's in this loop. So how does this really work? Well, pretty much what happens is we have the while loop here, we have the condition. So this is true, this means we're going to do this. Now what happens is we actually come back up to the top after we've done this and we say, well, is this condition still true? Well, yes it is, so that means now we're going to do this again. And we just continuously do this until eventually the condition is equal to false, or we have a keyword appear called break. like this. Now I'll do an example so we can understand this, but this is just the basic syntax. We have while, we have a condition, and then we have a colon followed by an indented block, which will be whatever's going to run. Okay, so let's start off by using a variable. We're going to just call it loop, and we're going to set it equal to true. Now we're going to make our while loop. We're going to say while loop. Now, by just putting a loop here, it defaults to say while loop is equal to false. Putting loop there is the exact same thing as typing this. It's just shorter to put loop instead of doing the equals equals true. Okay, we're going to get some input from the console. So we're going to say name is equal to input. And then I'm just going to put in here insert something. Okay. And then we're going to put an if statement, which we talked about in another video. So if you haven't seen that, go back and check that out. We're going to say if name is equal to stop. Then we are going to break out of the loop by typing break, or we could also do this. We could set the condition equal to false. So we set the variable up here equal to false. Now I know I just typed a lot there, so let's talk about what really is going to happen. So we have our condition. We say while loop is equal to true. Right now we set it equal to true up at the top, so it's going to automatically run at least once. Now we get input from the console and store it in the variable name. Now we have a basic if statement here that pretty much says if name is equal to stop, well then we're going to stop the loop and we're going to break out of it. Otherwise, we're going to keep asking the user to insert something until eventually they type stop. So let's see how this all works. Okay, so insert something, I say 1, 2, 3. It didn't like that. Once we insert something again, I say we. Okay, what about hello? Keeps going. Okay, now I'm going to type stop. And you see that the program stops running. Okay, so again, I'll show you that we can do this by just setting the variable equal to false. Same thing again, if I type hi, keeps going, I type stop, it's going to stop. And then maybe if we get rid of the variable here, we can also just type in the word break. Like that. And same thing again, if I type in some random things and then I type stop, it stops. Okay, so pretty much the way that the break keyword works is by simply saying, okay, are we inside any loops right now? It checks whatever loop you're inside. So right now we're inside the while loop, and it says, okay, well this line has now run. So what we're going to do is we're going to get out of the loop. So it pretty much will now start reading from the next blank line in the file, meaning that it's going to get out of this loop and just continue going down the program. Okay, and that's pretty much it for while loops. We can talk a little bit more about why we would use a while loop instead of using a for loop. The reason we might use a while loop is for something like this. So for example, if you want to ask someone to insert a password, so we have password like this, and we'll just change this variable to password, so pass for short. And now maybe we wanted to check, we wanted to say, well, let's just do password because pass is a keyword in Python. I forgot about that. Password. And we want to make sure that the password has, for example, at least one letter in it. Well, we're going to keep asking the user to re-input their password until it meets the certain criteria. So, for example, it might have to have one capital. It might have to have one letter in it. It may have to have a few numbers, something like that, right? So we would keep asking the user for a password until they gave it to us correctly. Now, the reason we wouldn't use a for loop for this is because a for loop, usually we know how long we want to run the for loop for. That's why we put a number in the range. So, for example, we put 10 or we put 12. While as a while loop, we don't know how long we're going to run it for. So, for example, someone could get the password first try, like they could put it in correctly with the right criteria, or it could take them 30 tries, right? We don't know how long it's going to take them. Okay, so that's it for today's video. If you liked the video, please like it and subscribe, and I will see you again tomorrow with a new video. Hey guys, welcome back to the 8th video in my Python programming series. Today we're going to be talking about lists. Now lists can be fairly complex, but they're a very important part of Python and they are very important to understand. So a list is another data type. So before we talked about strings, integers, booleans, and floating decimal points, so floats. And today we're going to talk about lists. So lists again are their own data type. So let's just start off by doing an example right now. So pretty much a list, which is denoted by the square brackets here, is a collection of different data types. It could be the same data types or it can be different data types. So for an example, I'm going to put a apple in here in my list. I'm going to put a comma and I'm going to add another item. So maybe we'll put a pear and then maybe we'll put a number as well. Okay, so we have the list fruits. And in the list, we have 3 items. Now, everything here separated by a comma is known as an item. So for an example, our apple is an item, our pear is an item, and the integer 3 is an item. Now, you can see that they're all different data types, or sorry, there is different data types. We have 2 strings and we have 1 integer value. Now, this is fine. You can store different data types in one list. Okay, so now let's just print the list to the console so we can see what it looks like. Print it out, and you'll see we simply get exactly what we've typed into the IDLE. So we get apple, pear, and 3. Now, if we want to access an individual item in the list, we need to do something a little different. So right now we just printed out the whole list, but say we want to just print out pear. Now what we're going to do is we're going to use the square brackets. So we're going to do the list name, so fruits, and then we're going to put square brackets right beside it, no spaces, and then inside of the square brackets we're going to type in what's known as the indice of that item. So the way indices work in Python is when you create a list, everything is automatically assigned an indice. So in this list we have indices 0 through 2. Now, it may seem weird that we start at 0 instead of 1, but that's just the way that computers count and the way that they work. So we have to understand that apple is going to be assigned the integer value of 0, so the indice 0, meaning I would put 0 in here if I wanted to access apple, because that's the first element in our list. And then we have pear, so that's the second element or item. Now that's actually going to be represented by 1 here. So fruits 1 will give us the value of pear, and then fruits 2 will give us the value of 3. Now this is sometimes difficult for some people to understand, but just really try to remember that the first item always is 0. So if you would like to access the second item in your list, you're going to type in 1 into the indice thing here. Okay, so I'm just going to run this and show you how this works. And you see we get pear. Okay, that's because we have the first indice, which represents the second item, which is pear. Okay, now there's some other things we can do with lists as well. So if we want to add something to our list, there's a few ways that we can do it. The first way, which is the only one I'm going to show you right now, is probably the easiest, and simply what we're going to type is fruits followed by the dot. So a dot, a period, and then we're going to type append. Okay, now this means to add to the end of the list. So inside of append, I'm going to put the element or the item that I'd like to add. So say we want to add another fruit. Let's think of another fruit that we could add, maybe a strawberry. Okay, we want to add strawberry into the list. I'm just going to get rid of 3 so it makes more sense. Okay, so right now in our list up here we have fruits, which is a variable name containing the list that has apple and pear. Now we want to add strawberry to the list. So let's start off by printing the list before we add it. So we'll print off fruits, and then we're going to print fruits one more time after we add this item to the list. And you see we have the first list, which is what we defined originally, and then when we added or appended strawberry to the end of it, it added it in just like this. So that is a way that we are able to add things into a list by using .append. Now there is another way, it's known as the slice operator using something called insert, but we're not going to do that right now. We're going to talk about the slice operator in a later tutorial, so stay tuned for that. Okay, so fruits.append, we've added strawberry. Now if we wanted to add another item, we could do the same thing, and we could do append again, and we could put in another fruit. Maybe we want to put in a blueberry. Okay, just like that. And again, we'll see that it does the same thing. We have apple, pear, and then apple, pear, strawberry, blueberry. Okay. All right, so that's it for adding to the list. Now, what about changing something in our list? So let's just add right here at the beginning. We'll put in strawberry. So we have 3 items. And now let's say we want to change the middle item in our list to a different fruit. Say we don't like pears, we want to remove it, we want to change that. So what we're going to do is we're simply going to type the name again, so fruits, followed by the square brackets, and then the indice of the item you want to change. So again, remember, if we want to change pear, we're going to use the indice 1, not 2, because this is the way that it works. We're going to use 1. And then we're going to change it to whatever we'd like to change it to. So say I want to change it to blueberry, I can do that like so. And then again, we can print out fruits, and we'll see if it works. Okay, so we get apple, blueberry, and strawberry. That's because we've changed the item at indice 1 into blueberry, and we've replaced that. We replaced pear with blueberry, pretty much. Okay, so that's how that works for a list, for changing items. Again, lists are very useful for storing large amounts of information. So this is a very small list, but in many programs we use something called multi-dimensional lists, which I'm going to talk about again in another tutorial. And yeah, so one more thing before we end it here. There's another data type called a tuple. So a tuple, it's kind of a hard word to pronounce, but it's used for coordinates, and it's also used for things like colors and rectangles. It can also be used just to hold information as well, but it's a different type of data type than a list, so we're going to talk about it quickly. Okay, so a tuple pretty much looks like this. So if we set a position, and we set it equal to something like this, not in square brackets, in the regular round brackets, and then we simply put the items in like this. Now we see we get it looks very similar to a list, the way that it works. Again, we can use different data types, so I could put something like hello in here as well. But it does function a little differently. And again, things like colors, we would also store in a tuple. So we would use like 255, 255, 255. That's simply white in red, green, blue colors. And again, if we print out the type of the color, you can see that we get a class tuple. Okay, so I'm not going to go too in depth with the tuples here. I just wanted you to understand what they are because we may be using them in some later tutorials. Okay, so I hope you learned how to use lists and a little bit about tuples today. They're going to be important in the next tutorial. So yeah, I hope you enjoyed. If you did, please like and subscribe, and I will see you in the next video. Hey guys, welcome back. Today we're doing the 9th video in my Python programming series, and today we're going to be talking more about for loops, so a more advanced type of for loop in terms of iterating through a list. So you may remember a few videos ago we talked about for loops, and I mentioned that there are 2 main type of for loops that we can use, and the one that we talked about there looked like this. So we had for x in range, and then we had a range like this, and we simply printed out the numbers like this. So we see we got 1 to 10 just like that. Okay, so that was the for loop we talked about there, but the one we're going to be doing today is a little bit different. So I'll leave this here for an example. So the first thing we need to do is we need to make a list, because we're actually going to be iterating through every item or every element in the list. So again, I'm just going to use the same example I used in the other video, fruits, and I'm going to make it equal to, we're going to have apples, pears, and strawberries. Just like that. Okay, so we have our fruits here, and now we're going to get right into the syntax for this new for loop. So we're going to do for, and then any variable name we'd like. So in this case, I'm going to use fruit, and then we're going to use the keyword in once again. And then instead of typing range this time, we're going to type the name of the list we want to iterate through. So in this case, it's going to be called fruits, just like that. And now we can print out the the fruit, just like that. So pretty much what is going to happen is we have a list with 3 items in it. We have apples, pears, and strawberries. Now we want to print every fruit in that list. So we do that by saying for fruit, in fruits, meaning for every item in fruits, so 1, 2, and 3 items, we simply want to print out that fruit. So this loop is going to run 3 times, and we're just going to print out every fruit inside of the list, just like this. And there you go, we have apples, pears, and strawberries, just like that. So yeah, that's pretty much how you can iterate through a list. And same thing, if I want to add more elements to the list, so at 8, 90, just like that, again, it'll just simply print out all of the items in the list. Now, why might we do this, you say? Well, there's a few reasons we may want to iterate by item rather than by indices. So the other one, the in range, is known as iterating by indice or by index, while this one is known as iterating by item. So there's a few reasons we might want to do this, but the first one is if we only want to print something out if it's a certain value. So we just want to check through all of the items in the list and see if they're a certain value, and if they are, then we're going to print it out or we're going to do something specific to that item. So in this case, I'm going to say if fruit is equal to, for example, pears, then I want to print out pears. So we'll just print out the fruit. But if it's not equal to pears, so anything else, then I will print out not pears, like that. So this is an example of how we can look through every item in the list and simply check if it is a certain value, and then if it is, we're going to print it to the screen. So we'll try this, and we see we have not pears, pears, and then followed by a few more not pears. So that's a good way to do it, by item. Otherwise, we can still do this using indice. It's just a little more complicated, or not as efficient. So we could do for x in range, and then in this case we'll do 0 and 6, because we have to do it 6 times because there's 6 items in the list. And then we'll put a colon, and then we'll say the same thing. So except this time we're going to say if fruits followed by the square brackets, and then x, because this is going to be our indice, equals pears, then we want to print fruit or fruit x. Oops. Otherwise, we'll print not a pear, just like we did in the other loop, not a pear. Okay, so we'll run that. And we see we get it twice just because I had 2 for loops there. So it does work the exact same way, except you can see that this one takes longer to write because we actually have to put the list name followed by the square brackets, whereas in this loop, all we have to do is simply type in fruit because it's automatically going through the list. Another reason too we may want to do that is because in this case, we had to actually see how many items were in the list by counting. And then we had to put that number in, whereas here it'll just stop at the end of the list automatically. Now we could do this, so len, this is a new word, so I'm just showing this now. This means length, and then inside we can put something like a string or a list. So in this case I'm going to put the length of fruits, and that would give us a value of 6, and you'll see if I just get rid of this, that it'll work the same way again by using the length of fruits. Okay, so that is how to iterate through a list by item. I hope you enjoyed. If you did, please leave a like and subscribe, and stay tuned for more videos in this series. Hey guys, welcome back. Today we're going to be doing the 10th video in my Python programming series, and today we're going to be talking about string methods. So a method is simply something you can call on a string by using the delimiter of a period followed by whatever the method is and then brackets like this. Now sometimes we have to put some things inside of the brackets, but most of the time we can just leave them with empty brackets. Okay, so let's get right into an example. We're going to start by talking about the dot strip method. Now what this one does is it pretty much removes all of the leading and trailing white spaces from a word, or from a string, sorry. So we'll start by just making a variable, and we'll make it equal to the input from the console, and we'll just say input something like that. And then we're just going to print out our input. So print out text dot strip. Okay, so again, what strip does is just going to remove all the white spaces before and after the word, and it's best to show you with an example. So you can see if we type a few spaces, so 1, 2, 3, 4, and then I type hello, and then a few more spaces, and I click enter, it simply gives us hello. That's because it had removed all of the spaces from the string. While as if I don't have the dot strip here, so if I get rid of that, and we run it, and I do some spaces again, and I type hello and some more spaces, it's going to give us those spaces as a part of the string. And most of the time, so when we have a string, we want to remove these spaces, so that's why we use dot strip. Did I spell that right? Strip. Yeah, just like that, okay? Alright, so that one's pretty straightforward, just removes these spaces. Now you may want to do this if you're checking if a string is equal to a certain thing and you're getting a user input and they may have accidentally typed a space before or after the word, right? Okay, so now we'll move on to the len. So this one is actually not a method because you don't call it using a dot, using a period followed by the word. It's actually known as a function, which I'll get into later. So this just means that it takes something inside of the brackets. So this stands for length, len, and pretty much what it does is returns the length of a string or of a list. So right now we're going to use a string and we're going to put text in here, and I'll show you again what it does. 1, 2, 3, 4, 5. Remember, although this is a number, since I'm typing it in the console, it actually gives me a string value, so this will work. And it says that the length of this is 5. Again, that one's pretty useful. I used it in the last video to determine how many times we had to iterate through a list because we got the length of the list. Alright, now for dot lower. So pretty much what dot lower does is it turns everything into lower cases in our word. So again, it's best to just show using an example. If I type something like this, with a few lower cases, a few capitals, and I click enter, you see we get everything in lowercase letters. Alright, and now for dot upper, you can probably guess what this one's going to do. It's the exact same thing, except in this case, everything is going to uppercase. So, like this, and you see we get all uppercase letters. Alright, and now for the last string method that I'm going to talk about. Although there is tons of different string methods, there's probably over 40 or 50. I'm going to leave the link down below to all of the string methods on the Python website, so you can go check them out if you'd like to see some more. So this one is called dot split. Now this one I'd say is probably one of the most useful methods that I use all the time, and what it does is it actually creates a list out of the string that you give it. So inside of these brackets, you're going to put what's called a delimiter. And what a delimiter is pretty much what you want to split by. So for example, I'm going to put a period in here just so we can get an example. So we have text.split, and inside of the brackets for dot split, we have a period. So it's best to just show an example. Oh, invalid syntax. I think I have one too many brackets there. Yes, I do. Okay, so we'll run it. So I input something. I'm going to type hello dot tim dot by dot hi, just a few random words, and you can see they're all separated by a period or by a dot. Now when I click enter, you see we actually get a list with all of the words, and you notice that we don't actually have a period in this list. That's because the way that dot split works is it gets rid of the delimiter. So since the delimiter was a period, it's not going to include the period in this list. Now this may be kind of confusing. We'll do a few more examples to hopefully you can understand. So usually what you do is you would leave these brackets blank, so you wouldn't put anything in them. And by default, Python's going to say, okay, well I guess you want to delimitate by a space. So the way that we can do this, again, what will happen is if I type a sentence like, my name is Tim, and I click enter, you see it separates by spaces, and we have no spaces in our list because it removes those spaces. Now you could also delimitate by anything you like. So I could do an A, for example. Now if I click F5 and we just type a bunch of letters and I put an A and then another A, you see we get the letters, and again there's a space at the end because I typed a space, right? So yeah. Okay, so that's how dot split works. Now dot split's very useful if you want to do certain things with a list. We're going to talk a bit more about it later on. But those are just some basic string methods that we talked about today. Again, there are tons more on the Python website, which I will link down below. If you liked the video, please like and subscribe, and I will see you again later. Hey guys, welcome back to the 11th video in my Python programming series. In today's video, we're going to be talking about the slice operator, which is a cool thing that we can use on lists and strings in Python. So if you remember in the previous video, if we wanted to access an element in our list, we did fruits, so the name of our list here, which I've already got defined as apples, pear, and strawberry. And then we would do the item. So for example, fruits1, and we can print that to the screen. Just to remind us what this did. And we got pear, just like that, because that is the second item, but to reference that we have to use 1, because in computers we start at 0, right? Okay, yeah, and I just wanted to mention, I don't think I did this in the list video, that you can actually do this on strings as well. So say I wanted to access the E there, I would just do text1, and we get the E, because that is the second item in this string, or character. Maybe I wanted to do the 11th one. Then that would give us another E because 11 is right here at the end of like. So yeah. Now what does the slice operator look like? So pretty much the slice operator is these two square brackets, but inside of them you're going to put 2 colons, just like this. Now these colons, in between them we type some words. Or we're going to put some numbers, but in this case I'm just going to show you with words. So we have start, stop, and step. That's what goes where these colons are. Now if I remove this colon, that means I just have a start and a stop. And then if I remove this colon, I just have a start, and that's how we reference what element we want to print out, right? If we had just put a number there. So we'll add the colon back in, and now we're going to use numbers. So the start, stop, and step works exactly the same way as the range function. So you may remember when I did a for loop, we did for x in range. And then inside of the range, we did some numbers like this. So we would start at 1, stop at 2, and step by 3 like that, right? So it works the exact same way, except in this case, we're going to be using it on lists and on strings, right? Without these numbers of the range like this. Okay, so let's just do an example. So let's start at 0, and let's end at this O. So the O is 1, 2, 3, 4, 5. But if I want to actually include the O, I have to put 5, because remember 5 would be this space here. And if we stop on, so let's say 4 here, you'll see what's going to happen. It's not going to print out the O, because when we stop, we do not include that number, remember, from the range function. So if we want to have the O, we'll stop at 5, just like that. Hello. Okay, yeah. Now, if we wanted to start just from the beginning, say we didn't know, all we have to do is just put nothing there, and it's going to default start from the beginning, so it'll give us the same thing. And then if we wanted to start from somewhere, so say we want to start at 2, and we just want to go all the way to the end. Now, we don't know how long our string is. We don't want to count all of these things and say, oh, well, let's stop at 17 or whatever number it may be. By just leaving this blank, it'll actually default to stop at the end of the string, and you'll see that. So we get LLO, I like Python, right? It stopped at the end of the string automatically. Okay, so now let's talk about the step feature. So if we want to start at the beginning and we want to stop at the end, we'll just put nothing in between these 2 colons, because it's going to default from the beginning and default to the end. But now we want to skip every other letter. That means we're going to put a 2 here for the step. So that way we're going to get H, L, O, then we're going to skip the space here. We're going to get I, skip the space, get L, and so on. So I'll show you. And you see we get that, a bunch of gibberish like this. Maybe we want to go every 3rd letter. That means we would step by 3 like this. And there we go. We get a few less letters. And same thing, we could do 4, 5, and continually going. Now say we want to start at the 3rd letter, or the 4th, because we're typing 3 here, so L. We want to stop at the end, and we want to step by 3. then you can see what's going to happen there. So we get L-I-I-T-N, right? So a bunch of gibberish. Okay, now this works again, same thing for fruits. I don't have as many items in the fruits list, so that's why I was showing you with text. But if I put the colon in here and we put another colon, let's say let's start at 1, so that means we're going to start at pear. And let's just go to the end, and we'll print that out. And again, we get pear and strawberry, so we didn't include the apples because we started at pear, right? So yeah, that's pretty much how the slice operator works. Now there is one other cool thing we can do with the slice operator, and it's called the insert function, or the insert kind of thing with the slice operator. So if you remember, when we wanted to add something to a list, we used .append, right? So I showed you that in my list video. We did fruits.append, and then maybe we wanted to add blueberries like this. I know that's spelled incorrectly, but there we go. We'll fix that quickly. Blueberries. Okay, and then we can print out fruits once again just to see what it looks like. So if you remember, this just adds it to the end of the list. But say we don't want to add blueberries to the end of the list. We want to add it in between pears. We want to add it in between apples and pear. We want to add it at the beginning. We want to add it somewhere else, right? How would we do that? Well, we can use the slice operator to do that. So instead of using the .append, we'll use the slice operator. So we'll go like this. And this time, we're going to just put 1 colon and then type the indice where we want to insert it. So if we want to insert it at the beginning, we're just going to type 0 and then 0 like this. We do need to do them on both sides. And then an equal sign, and we'll set it equal to whatever we want. In this case, we'll just put B for simplicity. And you'll see we get B at the beginning of our list. Now say we want it in between apples and pear. Well, in that case, we would put 1 and we would put 1 again like this. And we get apples, comma B, comma pear, comma strawberries, just like that. Now, if we want to add it to the end, we would have to find out what number that is. So we do 3, 3. I believe that should work. We'll see. Yeah, so that adds it to the end for us. And then if we want to insert it in between pear and strawberry, we would do 2, 2, like that. And there we go, we get it in between there. So that's how the insert works for the slice operator. I hope you learned how to use the slice operator today. We will be using it a little later in some other videos and doing some more complex things with it. If you liked the video, please like and subscribe, and I will see you again in the next one. Hey guys, welcome back to another video. This is the 12th video in my Python programming series, and today we're going to be talking about functions. So this is a function up here. We're going to talk more about the syntax and what a function does, but it's first important to understand what is a function. Well, if you're in math, you know that a function, pretty much you pass it an x value, and then it does something to that x value, and you get a y value back. Well, it's a similar idea here in Python, except there's different types of functions that can do different things. So the first function I've just written right here, pretty much I've named it add2, and what happens is we give it an x value, and then it simply returns x plus 2. Now this doesn't have to make sense to you right now, I just want to show an example of what a function looks like. So if we wanted to make our own function, what we would type is we'd type def, this stands for definition, and then the function name. So maybe in this case I want to do another math related function, so I'll do subtract 2, and 2 as a word, and then I'm going to put 2 brackets, and inside of the brackets we're going to put something that's called a parameter. So in this case I can name it anything I want. I'm going to put number in here, and then I'm going to do a colon, click enter. It should tab me in one space, and I'm simply going to return number minus 2. Now, I'll talk about what all this really does a little bit later, but I just want to give some examples. So now, if we want to call our function, or we want to actually use these functions, we have to do something. We can't just leave it like this. I'll show you if I run this right now, nothing's going to happen. What we actually have to do is we have to do a call statement. So what I can do is I can do add2, and then in here we have a parameter x. But what's actually going to happen is I have to give add2 a number, because we're going to add 2 to that number and it's going to be returned. So let's say 7. Now you'll see what's going to happen here. I'll run it quickly, and nothing prints out to the screen. That's simply because we haven't printed anything. What actually happens is in this add to call statement, we have it sets x equal to 7. So it comes up here and it says, okay, we're going to add 2 to 7. So we have x here, we add 2, and then we're going to return that back down here. So pretty much we call this function and it returns it right here. Now I have to set this equal to a variable or simply print it out to the screen. So I'll set it equal to a variable right now. So I'll say new number is equal to add to 7. And now if I print out new number like this, we get 9. Okay, so that's how that works. All right, now what about subtract 2? So we can do the same thing here with 7. So we do subtract 2. We'll leave 7 in here for number, and you'll see we get 5. So that works correctly. Now I can do it again. I could do 12, and we get 10. And maybe I could even change what I want to do in these functions. So this one's called add 2, but maybe I wanted to add 2 to x, and then I wanted to square it. So then I would do that. And then if we go back to the add 2, so I'm going to put 12 plus 2 squared, which should be 14 squared, which will be a pretty big number, which will give us 196, just like that. So you can kind of see and understand how these functions are working. They have a parameter. This is what that's called up here. So a variable name, I could do x, I could do y, I could do z, doesn't matter. I can do any letter I want, any name I want. It makes sense to call it something that makes sense in terms of the function. So here x works fine. But if I was doing a string, so maybe we want to write another function. Let's do another function here, and we'll do define, and we'll say print string. And now inside of here, I'm just going to put string like that as our parameter name, and then we're simply just going to print the string to the screen. So now what actually happens is instead of setting something equal to a variable, all I have to do is I have to do print string. This is my call statement. And then in here, I'm going to give it a string. So I'm just going to type hello. And you'll see if we run the function, we get hello. And we didn't print it down here. We just printed it from the function. So I know I've gone kind of fast, but the easiest way to understand the functions are to show examples of them and how they're working. Pretty much there's a parameter. I'm going to give the parameter. I'm in the argument of the call statement. So this, in the definition of the function, is called a parameter, and in the call statement in between the brackets, it's called an argument. So those are just some key words. Now I can actually use these functions as many times as I want. So I can print string again, and I could print my name is Tim, just like that, and you'll see it should do it twice. Yeah, there we go. So that's why these functions are extremely useful. Because say, for example, I'm writing a big program, and I know that I would need to do a certain thing multiple times. Well, I don't want to have to constantly write it out in the main line of my program here, when I can just have a function that's going to do it for me, and all I have to do is call that function using a simple call statement like this. So we haven't really done many big programs yet where functions make sense, but you'll see when you start programming that you're going to be using a lot of functions to do things because you're going to be repeating code. Now these are very basic functions. We have subtract 2, add 2, but you can have like physics functions, for example. If I know I need to find the acceleration of an object, then maybe I would make another function here, and I do define accel. I'll just do it like that, short form, and then I'll put in mass and the force like that. So you see I can actually have more than one parameter. I can have two parameters here, and I'm going to say A is equal to mass times force. I know that's not correct, but we could do something like that, mass times force. And then I could return the variable A. And now if I called my accel function and I printed that to the screen, well, that would give me what the acceleration would be, right? So those are just some examples of why functions are extremely useful. Well, you're going to talk more about functions. I'll do a more advanced tutorial a little later on, but this is just an introduction so that you can hopefully understand how they work. Pretty much you have, if you're writing a function, you have the def keyword, you have the function name, so in this case it's highlighted in blue, so I did add 2. Then you have brackets, and say, for example, when we did a function, we can actually do one without a parameter. So I could do define do something, and in here I could simply print hi, right? I don't need to have any parameters. That just means when I call this function, so do something, I don't put anything inside of the brackets, right? We just do this, and we see hi, hello, my name is Tim, right? So yeah, it doesn't have to have parameters. It can have multiple parameters. If, for example, in this acceleration function, you have multiple parameters, that means that when you call the function, so I'll do an example here, then you're going to have to put two numbers in, or two strings. So do 2, 5, like that. And we'll print this to the screen because we don't print it in that function, so we can see what we're getting. So yeah, we get hi, hello, my name is Tim, and then 10, right? So acceleration 2, 5, okay? So yeah, that's just the basics of functions. We're going to talk more about them in depth later, but just try to understand how they work. And yeah, so if you liked the video, please like and subscribe, and I will see you again later. Hey guys, welcome back. This is the 13th video in my Python programming series. And today we're going to be talking about reading from a file, so specifically a text file, and we're going to be using something called file.io in Python. So the first thing we need to do before we can read from a file is we need to create a file. So I'm just simply going to go and find the directory where my Python tutorials are. So, oops, not here. They are right here in the tutorials folder. And now you see I've got all my Python scripts right here, and all I'm going to do is I'm going to right click and I'm going to click new, and then I'm going to find text document like that. Now I can name it whatever I like. I'm just going to name it file for right now, file.text. Now you may want to populate the text document, so put some words in here. So I'm just going to put a bunch of different words. Hello, Tim, Python, learning, easy, just some random words in my text file. I'm going to save that. And now we can go to reading in the text file. So it is important that when you make the text file, you do have to save it in the same directory as your Python script. So if I were to put the text file here on my desktop, and I have my Python script in the tutorials folder here, it's not going to be able to find the file properly. You would have to do something which is a path joining, which I'm not going to talk about in this video, but maybe in a later one. So make sure that you save your file in the same directory and same folder as where your script is. Okay, so now that we've done that, we're going to read from the file. So the first thing we need to do is we need to create a variable. So we're going to name this file. You can name it whatever you'd like, and you're going to set it equal to the keyword open, and then inside of open, all you're going to do is you're going to type the name of your file, so file.text, a comma, and then the mode you want to open your file in. So in this case, we want to read it, so we're simply going to put a lowercase r inside of the quotations, just like that. And now that's pretty simple. That's all you have to do in Python to open up the file and to prepare to read it. Now, make sure you do put R in here. If you put nothing, or you put a W, for example, which would be write mode, it's actually going to clear the whole file, which you don't want to happen. You want to leave the contents of the file in there, right? So we need to open it in read mode with this R. That's very important. Now what we're going to do is we're simply going to read all of the things from the file. So we've opened the file. Now we need to read it. So in order to read the file, we have to type a few things. So we can do it in multiple different ways. The first way I'm going to show you is this. So I'm going to make another variable. I'm going to call it f. And this one, we're going to make it equal to file.readLines, like this. Okay? And then we can simply print out f just to show you what's going to happen. You see we get all of the words that are in the file. Now there's an interesting thing here. You may notice that there's a \n attached to all of the words except for the last one. That's because I'm going to open up the text file again and show you. You notice here I didn't actually type \n, but every time we click enter like this, it actually creates something called an escape character, which is that \n. So if we want to read in the file, we're going to have to remove that character afterwards, right? So it's just something to keep in mind that if you have things on different lines, each of the end of the lines is going to have a \n on that line that you don't actually see here in the text document, but Python will read that in. Okay, so we don't need to save that. Yeah, so let's move into the second way to read it properly now. So we have f equals file.readLines. Now we want to remove all of these backslashes, get rid of these ends from our lines. So there's a way we have to do that, and it's by using a for loop. So we're going to do a for loop. I'm just going to say for line in f, because now f has read all of our lines. So we're going to do what's called iterating by item, if you remember from my other videos. So each line, so every item in this f list here that just created by file.readLines, we're going to remove that character and we're going to create a new list. So let's make a new list. We'll call it new list. Just make it a blank list like this, new list. And then here we're going to say, what is it, new list dot append, and if you remember what append does, that simply means add to the end of this new list. And then we're going to add the line, and we're going to use the slice operator to remove that \n. So we're going to simply do the colon and then -1. Now what this does is it will take all of line except for the last character. So -1, I didn't talk about this in the other video, but -1 pretty much just goes to the last character, but does not include the last character when you do -1 like this. So just follow along for now. You don't have to completely understand it, but just put that -1. And now if I print out new list, we'll see what we get. New list, F5, and you see we get rid of all of the \ends. Now we have one issue here. Down here on ease, it should say easy, but we've actually removed the last \n from that string. So if we don't want to do that, now we need to actually add an if statement into our for loop. So inside of the for loop, we're going to type if, and then we'll say line, and we'll put a -1 again to represent the last character in that line, equals \n. And then we'll simply tab this in, because remember, everything in Python needs to be indented properly for it to be read. And now we'll try this and we'll see if this works. And there we go. So we get hello, Tim, Python, and learning. But now we've forgotten one thing. We haven't actually included easy. So now we need to do an else statement. So we have else, and then we'll do new list dot append, and we'll simply append the line just like that. And now we can print it out and we'll see what happens. And we get hello, Tim, Python, learning, and easy. Now there is an easier way to do this. I just want to show this example because you may want to do something where you're checking through all of the lines and you want to see if the last character or maybe the first character is equal to a certain item. And depending on what that string is, or depending on what it is, you may want to add it to a new list. You may want to do something to it. So I just want to show you a way that we can do that. Pretty much this is iterating through every line in the file. So file here, so F creates a list of every line, and then we go through every line of it, and we see, we say if the end of it has this \n, then we're going to remove the \n. Otherwise, we'll just add that line into our list, right? Okay, so now the easier way that we can do this is actually with something that's called the strip string method. So in my other video, I talked about this strip method that removes the spaces. But what we can actually do with this is we can remove, we can remove the \n with the strip method as well. So all we have to do here now, it's a lot simpler, is we do a new list dot append, and then inside of here, we're simply going to type line dot strip. And now this will automatically remove those \ns, and we'll see if this works. There we go. So we get everything, and you can see it's a lot simpler, and we don't even have to do the if statement for the easy, like that. So that pretty much is how you read a file in using Python. There are some other ways to do this, but this is the most basic and easiest way to understand. We've also talked about how to remove that, it's called an escape character at the end of the string, that \n. And in the next video, we're going to talk about writing to a file. I hope you learned something. If you did, please like and subscribe, and I will see you again in another video. Hey guys, and welcome back. Today this is the 14th video in my Python programming series, and we are going to be talking about writing to a file. So in the last video we talked about reading from a file, and now we are going to be writing to it. So the first thing we need to do is create a file. So we already have a file created here called file.txt. I did that in the last video, and inside we have nothing. So I'm just going to put the word hello in here so that we can test something out later. Okay, now it is again important that you have this file in the same directory as your script. So tutorial 14, which is the script I'm using right now, is in the same directory. That's important, otherwise Python will not be able to read that file properly. Okay, so now we're going to do the same thing we did in the last video. We're going to do file is equal to open the file name, so in this case file.txt. Oops, that has to be the lowercase, my bad. File.txt and the mode. So in the last one we used R, but in this case we're going to use W, and that stands for write. Now there's one thing we need to do which I forgot to do in the last video, and that is close the file. So we do need to actually close the file so that it saves our changes, which I forgot to do in the last video, and it's very important that we do that. So my apologies, but here we go, file.close. And again, if we had changed this name to anything else, then we would do that name.close, because the file is contained in the variable file, like that. Okay, so now we want to write to the file. So all we have to do is type the variable name, so file, and then .write, which is very simple. And inside here, I'll put a new word. I'm going to put Python, like that. Now before we run it, let's notice what is inside of our file.txt. So in here we have the word hello. Now I'm going to run the script. And nothing happens here, obviously, because we just wrote to the file. But when we open the file again, you see now it says Python. Now what actually happened was we removed the word that was in there before, so hello, and we overwrote it with Python. So what happens in this mode here, W, is it actually clears the entire file, and then it writes what you want to write to it. So if you have this W here, it is going to clear the entire file. Now there's a way to get around this, but I'm not going to be showing that in this video today. Okay, so let's write something else to our file. So file.write, and then I am learning how to write to a file, just like that. And again, we'll run the script, and we'll open the text file. And you see we get everything here on the same line. So that's okay, but you may want this to be on different lines. So how would we do that? Well, if you remember from the last video, there was something called an escape character that we got when we read in the file. We had that little \n attached. Now that's the same thing we need to do when we're writing to the file if we want things to go on a different line. So on this line here, I'm going to type the \, and then the n. And now what's going to happen is it's going to have this escape character, which is going to tell Python we need to move to the next line. And then it is going to type this right here. So we can show what's going to happen here. We go F5. And then if we open up the file once again, you see Python, and then I am learning how to write to a file. So that happened again because we use that \n, the escape character. Now same thing, we could use this in between a line. So if we want to write a large thing and we want it on different lines, then we can put the escape character in there like that. Same thing, open the file again, and we'll see what happens. And we see we get it on a different line. So that's how you can write things to a different line. Now this has been a pretty short video today, but that's really all it is to writing something to a file in Python. Now in the next video I'm going to show how we can write and read to a file at the same time, so that would involve not wiping the entire file when we open it. But if you learned something today, please like and subscribe, and I will see you again in another video. Hey guys, and welcome back. Today this is the 15th video in my Python programming series, and we are going to be talking about some more methods that we can use on strings and on lists. These methods are, I'm going to put them in a comment so that I remember, is the .find and the .count method. And now these can be used on strings and on lists. So let's go right ahead and give an example. So the .find method, this is a very useful method in Python. It's not in a lot of other languages, so it is specific to Python. So what we can do is we're going to make a variable. We're going to call it string. Now we can set this equal to whatever we want. So let's just say hello for this case for simplicity. And then we're simply going to print string, oops, if I spelt it correctly, string .find, and then inside of the .find brackets here, so the argument for this method, we are going to put in what we want to find. So we want to see if we can find the indice of any of these letters here. So if I put in L, you'll see what happens is I get 2. And that's because there's an L, the first L in the string is found at the indice of 2, just like that. Now you may be confused right now. I haven't completely explained it, but that's fine. So as you can see, we have 2 L's in the string, right? Now when I put in this L in the brackets, it gives me a value of 2. Now that is where the first L is found in the string. If I put in O, for example, you'll see it gives me 4. And there's only one O in the string, so it gives me the value of where that O is, which is the 4th indice of the string, the 4th index. If I put in H, you see we get 0. And now notice what happens if I put in a number or a letter that's not actually in the string. So I'll put in 7, for example, the string 7. And you see we actually get -1. That's because if Python does not find that inside of the string, it's going to tell you that it's -1. So rather than 0, it gives you -1, just like that. So this is useful because maybe we want to check in a password, for example, if it contains a certain element. So maybe if there's a dash in there, we don't want them to be able to use that password. Or maybe we're not allowing a certain character, or we need a certain character to be in a password or a string. This is where .find is useful. And it'll tell us if that's in the string or not. Now there's actually another useful string method here that is .count. Now it does a similar thing, except instead of finding the index of the letter, it counts how many of them there are in the string. So now we're going to go to .count. So we'll go .count like this. And again, inside of the brackets, we're just going to put a string. So let's do L. And you see if we F5 here, we get the value of 2. That's because obviously there are 2 L's in our string. Now I'm just going to type a bunch of random letters and show you that this does work for all kinds of things. So if I type in A, for example, we'll see how many A's I typed. We have 6 A's in that string. Now let's try a Z. I know I didn't use Z here, I'm pretty sure at least. Oops, that's my bad. We've forgotten a parentheses there. Sorry. Okay. And we get 0, right? So instead of -1, it counts and it says, well, there are 0 of them in the string, so we're going to return 0. Again, we can use this to find if there's a certain character in the string. So if we say you can only have a maximum of 3 numbers in your string, well, we could count and we could say if there whatever, how many numbers, right? The .find is different than this because it actually tells us where that is. So if I do .find again, and now maybe I put in an A. Well, we know there's 6 A's in the string, but which A is this one going to give us? So it says 5 because that is the first place that an A occurred in the string. So we see here at the 5th indice or index, that's where the first A is. It's not going to give us the A's from back here. If we wanted to find the A's back here, we would have to use a for loop, and we'd have to loop through the string in different parts of the string to find where all the A's were. Again, yeah, so that's how you use .find and .count. It's very useful if you want to check certain things. So I'll show you an example here. If we wanted to check a string, how we would use the .count method or the .find method. So I'm going to say if string .count, and I don't want to allow any, let's say, underscores in my string, is greater than 0. So that just means if it's, I guess we could also say not equal to 0. So if it contains at least one of these underscores, then we're not going to allow it. So we're going to print to the screen not good, just like that, okay, just to show how this works. Now here, instead of actually having a preset string, we're just going to get input from the console, so we can do this a few times and see. So input will say please type something as the prompt, like that. And otherwise, so an else statement here, if it doesn't contain any underscores, we will print good, like that. Okay, so now I'm gonna type hello. That was our first string. And oh, what happened there? Good, so we get good. Sorry, I don't know, something glitched in the program there. We'll rerun it. I'm not sure what happened there. F5, please type something. I type hello. There we go. Now we get good. I'm not sure what happened in the other one. Okay, so now let's do it again, and this time we're going to include an underscore. So we'll do underscore underscore hello. It's going to say not good because it counted these underscores and said, well, there is more than 0 underscores, so It's not good. And then same thing if we put an underscore in the middle of the word, or we put a ton of underscores, so HELO, whatever, just like that. Not good because there's underscores in the word, just like that. And yeah, that's pretty much how the .find and the .count methods work. There's a ton of uses for these, and it's really useful that they have this method, because in a lot of other programming languages, they don't have this .count and .find, so it makes it a lot harder if you're trying to find how many things are in a string, or if you're trying to find the index of a letter. So I hope you learned something. I hope you enjoyed. If you did, please like and subscribe, and I will see you again tomorrow for another video. Hey guys, welcome back. This is the 16th video in my Python programming series, and today we're going to be talking about Python modules and import statements. So this is something new that I haven't talked about yet, but Python is a modular programming language, meaning that we can use multiple files together to create one program, and you'll understand what I mean later in the video when I show some examples. But yeah, so pretty much in Python, at the beginning of all your Python scripts, what you typically do is you write something like this. It says import, and you can see this highlights in orangey yellow, meaning that it is a keyword in Python. Now there are many built-in modules, or what they called, in Python that contain a list of functions and classes that we can use in our Python script. So for example, the math module, import math. This allows me to do things like .square root, or the square root function, which I believe is like this, and then you can put something inside of it. So yeah, there's plenty of cool things like that. There's another module, it's called Pygame. We're going to be doing this later. I'm going to be talking about game development with Python. If you want to see that, leave a comment down below and I'll get it started soon. And then we have import. We could also import something called OS, and this gives us opportunity to do things like file paths and lots of different things like that. We can import images. We can import tons of different things into our files in Python. So we're just going to use the math module today for demonstration purposes. But pretty much what happens is there's a bunch of built-in modules in Python. So this one is known as a built-in module, math. When you download and install Python, pretty much you download that module. The Pygame module that I was talking about is not a built-in module. That means you actually have to go to the internet, you have to find it, and install it on your computer before you can import it into your Python program. And now what's really cool about Python is that it's an open source language, meaning that you can actually create your own modules, and they contain functions, classes, and you can use them in many of your different programs, or you can also send them to a friend maybe, or post them online for other people to be able to use. So let's get right into it, and let's do some things here. So if we want to use this math module, we have to first start by typing math. So the name of our module here, okay, so math, and then afterwards we're going to do the name of a function or a class in that that math module. So you see a bunch of things pop up there in that little box. So if I do the dot again and wait a second, it should pop up. Yeah, so there we go, and you see we have cosine, sine, tangent, all that stuff, degrees, factorial, all these things inside of our math module. So these are new things that we wouldn't be able to use before. So I'll show you if we do math.py and I print that to the screen, well, we should get an endless number of digits like this, math.py. Is it running? There we go. So it just had to print a bunch of numbers. So math.py, it didn't print all of them. I think it only went to 10 decimal points. So yeah, and then I'll show you if I comment out this this import math, what'll happen if I try to do this. We get an error because, well, math is not defined. We didn't import it at the top of our program. So we'll uncomment this now. Now I can do things like math.degrees. Degrees simply turn something that is in radians into degrees. So if I did math.py in here, for example, and we print that to the screen, we get 180 degrees like that. They also have the math.radians, I believe, which does the opposite. So it turns a degree into a radian. So if we did 60 degrees here, like that, and we get 1.047, which is about pi over 3 radians, like that. So yeah, there's lots of cool things that we can do with these modules. Now I'll actually show you an example of how we can use our own modules and how we can import our own modules into our function. So I'm going to just start by typing import. I'm going to type my module, just like this, okay? Now I haven't actually created this module yet. We're going to do that in just a second. Now I'm going to go and I'm going to find the directory that my main script is in. So it's in tutorials up here. I've got this open, and remember how we had the file in here as well, because it has to be in the same directory. So I'm going to create a new file in that directory. So file, new file. I'm going to save this one as my module. Now spelling is very important. Again, capitals do matter, and it has to be in the same directory as our main script, which it is, like that. Now inside of this module, I'm going to write a very basic function. If you haven't seen that video yet, go check that out first. We just talked about some basic functions and what they do and the use of them. So I'm going to define, I'm just going to call it my func, like this. It's going to take a parameter called x, and all it's going to do is return x plus 5. So very basic function like that, but just for demonstration purposes here, okay? And now I have my module imported like this. So I can actually use my module. So I'm going to do print my module dot my func, because that's the name of my function. And then inside I need to give it a number. So what number do we want to use? Maybe we'll use 6. And we print this out. And you see we get 11. So by simply, all I did was create a new file, put it inside of my same directory as this script here, and easy enough, we were able to use it. Now I can actually create multiple functions in here. So I can define another func like this. That'll be the name. This one will take x again. And inside here, I'm going to return x integer division 5. And then again, we could use that one. So instead of my func, we'll use another func like this. And let's just type in a big number like that and see what we get. There we go. So again, it's working perfectly fine. So that's how modular programming, is what it's called, works in Python. Now obviously, if you're going to be doing modular programming, it's usually for larger programs and bigger programs where you want multiple files to keep things organized. Say maybe if you're doing a flight simulator, you may have one module that includes all of your physics functions. So you know that when you need to do physics, you're going to import your physics function, and then you can, or module, sorry, and then you can use the functions from there. And the great thing about this is that these modules are reusable. In other Python files, I can import them and I can reuse these functions. I don't have to constantly rewrite them inside of my script like this. So this has been a very basic tutorial, just an introduction to modular programming. I showed the math module a little bit. If you want to learn about some of the built-in modules in Python, then just go ahead and go to their website and you can see a bunch of the different ones that they have. Another one that we may be using later is called OS, so the statement for that is just import OS. And if you want to get started with game development, you can look into Pygame, which is this cool thing that I'm going to be doing a tutorial series on later. So yeah, that's been the video for today. We talked a little bit about modular programming. If you enjoyed, please like and subscribe, and I will see you again tomorrow with more content. Hey guys, and welcome back to another YouTube video. This is the 17th video in my Python programming series, and today we're going to be talking about functions, more advanced functions, and something called optional parameters. So let's just give a quick refresher of what a function is. I'm just going to write one very quickly. I did do another video on basic functions, so if you haven't seen that yet, go check that one out first. Now here we've defined what we're going to call the function func. And then inside of these brackets, we put something called parameters, if you remember that from the other video. So in this case, I'm just going to put x as my only parameter. And then I'm simply going to print x to the screen just like that. So a very, very basic function, but it's just to give you a quick refresher of what it does. Now, when we wanted to call our function, all we had to do was write our function name and then put a brackets, or the brackets like this. And then inside of our brackets, if we had a parameter set, we had to give it that parameter. So we could do 3, we could do hello. Let's just do hello in this case. And we'll click F5 and we get hello on the screen just like that. Now we can change this again to maybe Tim, which is my name, just like that. And we get Tim printed to the screen. Very basic, very easy, just like that. Okay, so that's pretty much what a function is. Now, what we're going to be talking about today is more in depth on these parameters. So you remember we could give it multiple parameters. So we could do x, and we could do maybe text like this. So we had x and text, and we could print x to the screen, and maybe we'll say if text is equal to, let's say 1, so the string 1, then maybe we'll print text is 1. Otherwise, so else, we will print text is not 1, just like that. Very easy. Okay, so now what we have to do when we call the function is we have to give it another parameter. In this case, I'm going to give it 2, and we'll see what happens. We get Tim, and then texter, I misspelled that, my bad, is not 1. Now if I change this parameter to 1, again, we'll see that we get text is 1. Now, again, that's just another example, but in some cases when we call a function and we have many parameters, or maybe we don't have many, but we don't want to constantly be rewriting these parameters. We want to have something called the default value for our parameters. So x, maybe we always want to give our function the value of x, but in text here, we always want it to be set to something unless we otherwise specify. So in this case, I'm going to say text, and then the equal sign, I'm going to put 2, just like that. Now, here I'm going to remove the 1, and you'll see what will happen here. We'll just run it to show you, and then we'll go in what's actually happening. So we get Tim, and then text is not 1. So what actually happened here is, since I didn't specify a value for text, so I didn't do a comma and write something else here, it defaulted to the value of 2. Now we can prove that by just simply printing out text and showing you that it is actually 2. So we have Tim and 2, just like that. If I wanted to change this value now, all I would have to do is simply put a comma here in the function and change it to whatever I want. So in this case, I'll do 67. And if we print it again, you'll see we get 67. So that's how the optional parameter works. Now, all you have to do to set an optional parameter is simply type an equal sign after your parameter. So if I have x, and I'll set it equal to 3, like that. Now when I call the function, I actually don't have to give it any parameters, because it already has the optional parameter of 3 and of 2, which are going to be the default values if I don't write anything in my function argument here, so inside of these brackets. And you'll see again we get 3 and 2 because those are the default values. Now there is one tricky thing that you have to understand about these optional parameters. Say you wanted to have x stay at the default value, so you wanted it to be 3, and you didn't want to type 3 in the brackets like that, but you wanted to change the text optional parameter to something like 7 or 8, or maybe another string. Well, you can't actually do that. In order to change this text optional parameter, you would have to also set a value for x here. So if I try to, I'll say I just want to set the text to 3, so I'll do like 3 here. It's actually not going to change, sorry, what do you call it? I'll change it to something else so we can see it better. 5, let's do 5. It's actually not going to change that second variable, right? It's going to change the first one automatically because that's just the order in which they're defined. So if you have more than one optional parameter, you will have to set a value for the one before in order to change the one afterwards, like this. So that's the only tricky part about these optional parameters. Other than that, they're extremely useful. Again, you would use them if you're constantly using a function and you don't want to have to keep writing in parameters. You only want to give it a parameter in a very specific case. Then you would have that optional parameter already set, so you don't have to keep typing a certain word, or you don't have to keep giving it a value like that. So this has been a shorter video, but this is the video on how to do an optional parameter. They look just like this. They're very simple and pretty basic, and I hope you learned something today. If you did, please like and subscribe, and I will see you again in another video. Hey guys, welcome back to another video. This is the 18th video in my Python programming series, and today we're going to be talking about something called a try and except block of code. So just like we talked about the if, else, and elif block of code, and like we talked about the for loop, which is a block of code, and like functions, which are blocks of code, we're going to be talking about the try and except. So in Python, we use try and except as our keywords. In other languages, you may have heard of try and catch statements. This is the same thing, except in Python, instead of catch, we use except. Okay, so let's talk about what a try and except statement is. Sometimes in Python, you want to do an operation or you want to try something, but you don't know if it's really going to work or not. There's some different variables that may come in. Sometimes it may work, sometimes it may not work. Usually this depends on user input or what the user is doing in the program. So a good example of this is maybe if we're validating a form. So we'll do an example here. We'll say text is equal to input, like this, and then we'll say username. Okay, now in typical usernames, you're only allowed certain characters. Maybe you can't do a comma, you couldn't do a star, certain things like that, right? Maybe we only want it to be text or we only want it to be numbers. We just want to validate this. We could use a huge if statement to do this, but instead there's something called a try and except that we can use. So in this case, I want my username to only be numbers. So I don't want it to be a string at all. I want it to only be numbers. So what I'm going to do is I'm going to make a new variable here, and I'm going to call it number. And all I'm going to do is I'm going to try to int the text like this, okay? So if you remember, what the int does is that simply converts our string into an integer. And then I'm going to print that to the screen. So I'm going to print number to the screen. Now, what happens right here is if I try to type in a word like this, you see we get an error. It says there's an invalid literal for int with base 10. Now, you don't have to understand what this error is. Pretty much all this means is that we can't convert hello into a number because there is really no number there. How does it know what number to make that into, right? So in this case, we would use a try and except block. Because if the user types in something that's invalid, well, we want them to type in something else. We don't want the program to crash like it just did there. So here I'm going to put a try like this, followed by a colon, and then I'm going to indent these two blocks right here. So that means we're going to try this block of code. Okay, and then underneath here, I'm going to type except, just like that, followed by a colon. Now, there is a more advanced way to do this. We can accept a specific type of error, but I'm not going to talk about that in this video. This is just a very basic try and except block. And then under here, I'm going to type what I want to happen if this block of code doesn't run, meaning this block of code returns an error, and we can't actually execute it. So in this case, I'm just going to do, I'll just print to the screen, invalid username, because remember, we're only going to have our username contain numbers. Alright, so now if I run the program and I try to type in something that is not a string, so that is not a number like this, it'll just say invalid username rather than crashing the program, which is what happened before. And if I do try to type in something that is valid, so maybe I type 1 2 3 4, it just gives me that username back, right? So it works like that. So that's pretty much how the try and except works. Again, this is a very basic example, and that's what I try to do in my videos, just give you the basics, and then you can try to apply it to some projects you're doing, and some more advanced things. So again, what happens is it tries this block of code. If that block of code doesn't run or an error happens, instead of simply crashing the program and giving us that red message, it's going to go to this except block, and it's going to do whatever's in here. Now in this except block, again, we could ask them to type in a new username, we could display another message, we could maybe close the program on them. We could do whatever we want to do in this except block, and it's extremely useful. So yeah, that's pretty much how the try and except works. If you learned something, please like and subscribe, and I will see you again in another video. Hey guys, welcome back to another video. This is the 19th video in my Python programming series, and today we're going to be talking about a fairly complex topic some people find kind of confusing in their programs. It's very useful to understand, and it's global versus local variables. So global pretty much means everywhere, can be used in anything, and local means specific to a certain block of code or to a certain class. So let's just dive in right away with an example. So in our program, we have things called variables. Again, we've talked about them before. So I'm just going to say var up here equals 9. We'll say our true, this is lowercase here, is just equal to true. Or actually, let's call it loop instead, just not to confuse anyone. So loop is equal to true. And then maybe let's make a function. We're just going to call this function func. We'll give it a parameter of x. And we're just going to say if x is equal to, 2 equals sign 5, then return true. And we'll set a variable up at the top of this function, and we'll just call it new var is equal to 7. Or, yeah, 7. Let's do that. And then instead of returning true, we'll actually return new var. My bad. New var, just like that. Okay. So here we have 3 variables. We have the variable var, which is equal to 9, the variable loop, which is equal to true, and then the variable new var, which is inside of our function, and that's equal to 7. And then the parameter x, which again can kind of be considered a variable, but it is more specifically a parameter. So I just want to show you right away what tries to happen if I print out the variable new var. So outside of my function in its own line, I'm just going to say print new var like that. We click F5 and we get an error here. It says the name new var is not defined. But how can that be possible? We just made new var right here in our function. Well, this is where we get into local versus global variables. So the variable new var is actually known to be a local variable to the function func. So that means the only thing that's able to access the variable, change the variable, and use the variable new var is the function func. So again, if I put the print statement inside of my function and then I call my function, it will work. So here, if I type func now and I'll give it value of 2, then new var does print to the screen and we don't get an error. So that is how the local variable works. So again, it's the same thing in any other type of function. So if I write another function, I do define other func. This one I won't give it a parameter, and I'll just say new var is equal to 5, like that. So different than 7. And then this function will print new var. Well, do we think it's going to print out 7 or do we think it's going to print out 5? So we'll show you like this. If we run, take 0 positional arguments, other func. Oh, my bad, there's a 2 in there, sorry. It prints out 5, right? So it doesn't look at this variable here, it looks at the local variable in here called new var. Now same thing if I put new var up here outside of all of these functions and I set it equal to 23. And then I click F5 here to run, it's still going to print out 5. That's because these functions, they can see these variables up here, but if there's a variable already declared inside of their function, they're going to use that one instead. I know it's kind of confusing. I'm going to talk a little bit more about how this works. I just wanted to give some examples to start off. Okay, so now we'll talk about global variables. So local variables are ones that are declared usually inside of a function. So that means outside of the function. So again, if we tried to print new var out here, and I got rid of this up here, we get the error like we got before, right? It says it's not defined. So what about global variables? Well, these global variables are ones that anything in the program can see. So var and loop would be known as global variables. In here, if I try to print out our variable var, and then I'll just call that function by doing func, and I'll give it a value of 2 once again, it will be able to see var, and it does print it to the screen as 9. That is because this is global. It's not defined inside of a function or inside of a class, and classes we'll talk about later. Don't worry about that. Same thing if we try to print out loop. So if I change this to loop, again, it should work. We get true printed out to the screen just like that. So now there's the issue with changing variables inside of a function. So typically you want to avoid this. You don't want to be dependent on these global variables up here to make your functions work. This is because if you remember in my other video I talked about modular programming where we can reuse functions. Well, if I have a variable defined up here and my function is referencing that variable, meaning it requires that variable to work, then if I try to use this function in another one of my programs, it's not going to function properly because that loop variable or that global variable that I try to use is not going to be defined in that other program, right? So let's do an example here of how we can actually change a global variable. So if I go here and I say loop is equal to 7, so I call my function and it's going to set loop equal to 7, and then I try to print out the variable loop. Well, what do you think is going to print to the screen? Give me a guess. It's either going to be 7 or it's either going to be true. What do you think, right? So I'm printing it underneath after I call this function. Let's see. We get true. Now, even though we, what looks like, changed the variable in this function, instead of actually changing this global variable, instead we created a new variable which is local to the function called loop. If we want to change this variable, we have to use something called the global keyword. So in Python, what we have to do is at the top of our function, we just type the word global, followed by the variable name that we want to change. So in this case, I'm going to say loop. Now, if we run this program, we print out 7. That's because this tells our function that we're going to look outside of the function here for the variable. If it exists, then we're going to change it, just like we did there. So I know this has been kind of confusing. I've kind of jumped around. Try to play around with these things and see if you're getting errors. See if you can figure out what's going to print to the screen here. If you want to change a global variable, so one that you define at the top of your program here or outside of your functions, then you must type the global keyword inside of your function followed by the name here. Again, if I try to change the variable down here, so not inside of a function, it will work. So if I do loop is equal to false, then we get 7 again just because I called it up here, so I won't call this function this time. If I say loop is equal to false, then we will get false because it's not inside of a function, so it is able to see and change this variable. So really, using the global keyword, it's just inside of functions, and just remember that if you do create a variable inside of your function, it's local to your function, meaning that unless you type this global keyword first, and then followed by the name of that variable, everything outside of the function will not be able to see that variable. So if you liked this video and you learned something, please like and subscribe, and I will see you again in another video. Hey guys, welcome back to another video. This is the 20th video in my Python programming series, and today we're going to be talking about objects and a little bit about classes. In the next video, we'll go more into depth with classes, talk about creating our own classes and how we can use them, but today we just have to understand what objects are before we can move on to that topic. Okay, so what is an object? Well, I'm sure you've heard of an object before, and when you think of object, you think of something. So usually something you can hold, just something. Pretty much an object is something, right? Something tangible maybe is what you think of. Well, in Python, pretty much everything we do here, a lot of it is objects. So any variable that we create is actually an object. So if I create x and I make it equal to the string string, well, if I print out what type this string is, so print and then the type x, well, it's actually an object of the class string. And we've seen the classes before, we may not have understood what they are, but yeah, then if we do y, we set that equal to 23. Now if we print out the type of y, what do you think the class is for this, if you can remember back? Well, it is an integer, so it is an object of the class integer. Now, why is this important? Why do we care about objects? Well, objects have certain attributes. So an attribute is something we can do with the object. So just like we cannot add a string to a number, so we can't add a string to an integer. If I try to do x plus y, and we'll say like z equals that, then we should get an error here. We'll see. Yeah, we get an error because we can't convert int into string implicitly. And just like we have certain methods that we can use on different objects. So for example, if I try to do this, so I try to print out y.count. Now if you remember, count just pretty much counts how many letters are in a string or in a list. Like this, I'm going to count 1. We get an error there as well, and we say the int object, so object like we were talking about, has no attribute called count. But if I change this to x, then it works and it gives us 0, right? Because the string object does have an attribute called count. So these attributes, so all these little dot things here, we had dot find, dot count, dot index, lots of different dots, dot strip, all those things can be used on either strings or on integers. Now I've only shown string ones so far, but there are some ones that we can use on integers. And they have different properties and attributes based on what type of object they are. Same thing if we create another variable, and we'll just call this one boo, and we'll make it equal to true, right? We can't do boo.count. It's not going to work because there's no attribute on the object of a boolean to do that, right? The bool object has no attribute of count. So yeah, I hope you understand that right now. Everything is an object, and based on what type of object it is, it has different attributes. Now those attributes can be simply variables, they can be methods, lots of different things. You don't have to understand that right now. I just wanted to get that out there. So pretty much when we do this y.count or this x.count here, we're actually calling a method on x. So whenever we put a dot and then a name, so we had dot string, dot count, all these dot strip, all those are called methods. So they're built into the class, and we can use them on an object of that class. So I hope that makes sense for right now. It's different than if we made a function. So you know how we made the function func maybe, and we printed something to the screen. Now instead of putting, so we'll just print hello whenever we call func. Instead of doing like x.func, that wouldn't work, right? All we did to call the function was we put func like that, right? And if we run the program here, oh, we get an error just because I didn't put anything in here, but we'll get rid of that. If we run the program, we see we get hello, right? So we didn't do a name and then a dot. We just called the function like this. So functions and methods are different. It's just important to understand the difference between a function and a method. And I hope I've kind of explained that a little bit. We'll talk more about the methods in the next video when we do more on classes. Okay, so more about objects here. Pretty much whenever we create any type of variable, we create it as an object, right? So this x object has all these different methods on it, right? So it has dot strip, dot count, dot find. The integer object has some different methods that we can use on it as well. I don't really know a lot of the methods for integers, but if you go on the Python website and you look it up, I'm sure you can find it. Same thing with the Boolean class, right? There's lots of different things on there. So now that we've been talking about classes so much, let's do a brief introduction on what a class really is. So what does a class look like? Well, in the Python documentation, there's a ton of different classes. So every data type has its own class. So for example, a class might look like this. So class, and I'm just going to make this one, I'm going to call it number. And then inside of it, there's a few things. These are the methods that we create inside of the class. So they look just like functions, except they're inside of a class block like this. And they look just like this. And then we'll just do, we don't need anything for there. Define, let's call print, or just call display as this one. So I'm just making this one up here. This method up here is built into Python. I'll talk about what that does in a second. So define display, I'm going to put an X there, and then I'm just going to say print X. And then in here, I'm simply going to do, let's just do self.var is equal to 24. Okay, so I know I just did some things that seem pretty random to you, but pretty much what I did is I just created a class, just so that we can use it as an example to show you how another class works. So let's pretend this number here is actually an integer. Okay, so let's say that this is the integer class in Python. Now this initialization statement, that's what that stands for, underscore underscore init underscore underscore, and this self in the bracket, I actually need to do this in here as well, is mandatory in order to get the method to work. So we do need to have this self inside of the brackets. It always has to be there. Okay, so we've done that. And then let's pretend that's the initialization, right, for the integer class. So when we create this new object of an integer, what actually happens is it sets a variable inside of the class equal to 23. So here, since I have 23, it would make this 23. So let's just put this to 23, like that, okay? And then it has something called methods that can be called on the function. So if I were to do y.display, and then inside of here I need to give it a value, so if I put like 21, then it would display 21 to the screen. I hope that makes sense. That's the method part of the thing. Now when I just create this y variable and I create a new class of number here, or of int, whatever we're saying it is, then it's automatically going to do this init. So I don't have to do y dot underscore underscore init. It's automatically going to do this one whenever we create a new function. So let's just give an example here. Let's do number. So we're just going to make a new variable. So let's call num is equal to number. And then inside of the brackets, we don't have to give it anything because in here, I don't have a parameter. Now, if I had another parameter in here other than self, so for example, I did something like num, then I would have to give a number in this to allow it to work. So let's do that. Self.var is equal to num, and we'll talk about what self.var is in a minute. Okay, so then I've created that. Now if I try to print out num to the screen, we'll see something interesting. So we get main.number object at this location. Now this is a bunch of gibberish, means nothing to me really, other than it's the location in memory on your computer of where this object is stored. So whatever that means to you guys, but yeah, that's the location in memory of where it's stored. And I just wanted you to see that it pretty much is creating an object of the class number. So rather than creating a object of the class int or the class string, we're creating an object of our own class that we've just made in our program called number. Now, what do we want to do here? Well, why don't we try calling a method on our new class? So we use the name, so we'll do num.display, and now we need to give it a parameter in here. So I'm going to do something that may seem kind of confusing to you guys, but just carry around. Just follow along. I'm going to do num.var in this bracket. And when we run it like this, we get 23. So let's talk about what happened. So pretty much this display method, it takes one parameter of x. This self, just ignore it. It just needs to be in there to make this work. And the parameter that I'm passing it is num.var. Now, up here in this initialization statement, so when I actually ran this little line of code here, it ran this. Now, it created a variable inside of the class number called var. Now, this variable is global inside of this. So it's not fully global, but it's global, and all the functions that are inside of this class can see it. Now, that's because I put a little self and then a period beside the variable. If I had just done var.num like this, you'll see what happens. We actually get an error here because we can't see that variable. So we have to put the self before it like this to make it global, like that. So yeah, I know I've kind of gone quickly today. I just wanted to give you a brief example, hopefully get you guys to understand a little bit about it. In the next video, I'm going to talk more in depth about classes. We're going to create our own classes, and we're going to see some examples of why classes are useful. So that's been my video today on objects and classes. I know it's been kind of all over the place, but if you enjoyed, please like and subscribe, and I'll see you again tomorrow where we'll talk more about classes.